We are about to get started. Thank you so much for joining us early this morning. It's great to see some familiar faces. We're really looking forward to the great events of today. We have a lot of different ideas and topics to talk about. First, I would like to welcome Vice Chancellor Roger Wakamoto, who will offer some opening remarks, and then we'll get to some logistics.
So thank you, Deanna, and it's really great to see some people that I see frequently, but typically only on screen, so to be able to see them face to face is just wonderful. So what are my comments? First, I want to start by saying we often throw around the term disruptive here and there and say, oh, this is really disruptive, when it really doesn't deserve that label. But I think I'm speaking to the choir here that when we talk about AI, and in particular things like generative AI, this is clearly disruptive. This is really going to change the way we do things. It's like a speeding train that everyone is trying to hop onto. Some people are scared. I mean, let's be honest. Some people are very scared, very cautious about what they may find out, but others have been really excited and have embraced this AI and its future potential. You know, I find it truly amazing that you simply blink and there's an entirely new development that has come out of this field. I have to share a story with you. I was at a conference where there was an AI session. It was packed, and they had a list of very distinguished panelists talking about AI. And they were all asked to share an innovative approach with how they've used ChatGPT. One of the panelists quickly responded that he asked the following question: what anniversary gift should I buy for my spouse? I mean, I found that just amazing that here's an expert in this field, and that's what he asked. He didn't share with the audience what that answer was, but he said he did follow its advice. So there you go, how revolutionary it is. Let me share a few numbers with you, and I think some of you are probably aware of this. In just 5 days after the November 2022 release of ChatGPT, it already had acquired 1 million users. And then 2 months later, after it's released, the user list grew by 9,900%, which means that 900 additional users had signed on. And by April, it was already 173 million users. I think the case that that has been made by many people that I know at other universities, the students were so far ahead of the faculty. They were already just fully engaged with it before the faculty even knew really what they were dealing with. However, while most of the focus, I believe, at universities has been on the AI's impact on teaching and to a certain extent administrative services, I and many of my colleagues believe there's been really not much focus on AI's impact on research, relatively so. I won't say it's zero, but I think it's been disproportionate. So as a result, I strongly support today's theme of research in the age of AI and the focus on interdisciplinary aspects. I don't know if you read the news release that was literally just a few days ago. Jennifer Mnookin, our former dean of the School of Law, who's now the chancellor at University of Wisconsin-Madison, just released that she is allocating 30 FTE for faculty hires in the area of AI. So that's a lot, and that was very quick of her to make that decision. I love your agendas: fundamental of AI, innovative applications, implication of AI, and data justice. I'm also glad that graduate students have been trained in this symposium. I hope you all have a chance to visit the posters, because I know it was a long time for me and for you, but it's really important that you interact with them and make sure you give them good advice, and I'm sure they love to share the results that they have with you. So that's really all I had. I really wish you well. I hope you get a lot out of this, and turn it back over to Deanna.
Thank you so much, Roger. I'm also very excited for today, and it's great to see the representation of different disciplines across campus and the diversity. I want to thank all of our moderators, speakers, poster presenters, panelists, and also the amazing staff. And I'd like to thank the organizing committee, Andrea Bertozzi, Jeff Burke, Eleanor Cole, Mayak Mehta, Terry Tao, Susan Swartz, and Barbara Woltag, whom none of this would be happening without all of their great help. So sorry, there's their list. Some logistics. We are going to be using VVox technology to gather questions for the speakers, for those who prefer not to ask during the microphone. So if you're in the room here, we'll have some runners for mics, but otherwise you can use this VVox, just scan this QR code or go to the app. The session ID is listed here. It's also listed on the website. To ask a question, go to the Q&A message board by clicking on the icon that looks like a speech bubble. Toward the top of the screen, the Q&A is set to be anonymous. So if you want your name to be known, please include it at the end of the question. So our beginning two talks are talks on fundamental AI. We have a loosely structured day today around the three pillars, as Roger mentioned, of DataX, fundamental data science, which we're kicking it off with, innovative applications and creative activity, and data justice and critical data studies. Our two opening talks today will set a foundation for the day by addressing the mathematical foundations of AI and exploring the intersection of AI and intelligence. Our first speaker is Mayank Mehta. He is the director for the Center of Physics of Life and professor in the Department of Physics, Department of Neurology, and Electrical and Computer Engineering. He has developed minimal biophysical theories of brain function and tested those theories using in vivo multi-electrode experiments. His research has probed how neurons create abstract ideas, such as space-time using virtual reality. By the way, neither of these speakers need an introduction, but I'm giving the bios just to be thorough. Terry Tao is the James and Carol Collins Chair in Mathematics at UCLA. He has been a professor of mathematics at UCLA since 1999. His areas of research include harmonic analysis, PDE, combinatorics, number theory, and I'm pretty sure any area of mathematics. He has received a vast number of awards, including the Salem Prize, the Bochner Prize, the Fields Medal, the MacArthur Fellowship, the Waterman Award, the Nemers Prize, and he asked me to make this brief, so I'll just put a ... at the end there. He is also a fellow of the Royal Society, the Australian Academy of Sciences, the National Academy of Sciences, and the American Academy of Arts and Sciences. So first, I'll welcome Mayank Mehta to the stage, and then Terry Tao will follow.
Shall I be swapping out this? Or is there another? Should I take that out? Oh, I see. All right. Super. So, thanks everyone for coming here, and thanks to all the speakers for taking the time. I will briefly tell you a very wide range of things, and in the day of ChatGPT, what can I say that's already not found by a machine? So I'll try to do something hopefully that a machine cannot do as an illustration of where we want to go. And you may want to think of why is it that I was able to do some of these things, hopefully that GPT could not do. So I'm going to basically give you 3 take-home points. First, there are many kinds of intelligences, not just intelligent. We all have some idea, and what are those and so on. Second, what's different between brains and machines? Why do I think that I am intelligent and a machine can or cannot do something that I can, and vice versa? And third is the most interesting point, that there is actually a tango between the two. And while we human beings are afraid of GPT and or AI, what it might do to us, but it may be worthwhile to consider that how our technology is changing us, and this is nothing new. This has been happening for the longest time. So, quick questions. Are humans intelligent? Doesn't sound like it, but they are. Are all humans intelligent? Maybe not. All right. Is a human always equally intelligent? This is John Nash. While he was coming up with the fantastic theory of mathematics, he was believing that there are weird creatures outside which are talking to him. So it's the mapping between intelligence is we can conclude already that some humans are intelligent at some times, in some ways, and there's a huge variability. And we tend to forget this massive variability. Why is that? Machines don't have such huge variability. In fact, huge IQ is associated with greater mental illness and even immune system issues. So there's a funny link that about brain and body and all kinds of things that we need to keep in mind. On the other hand, if you're intelligent, well, you're less dangerous. So next question then, were humans always equally intelligent? Well, you could say, well, before Euclid, I don't know how much math existed, and now that's the gold standard of AI. But then there were pyramids before Euclid, pretty tough thing to do. There was abacus even before that. And now you can start seeing the tango between human technology and human thinking. Abacus came before, so the technology was necessary. Certain human abilities to develop the technology, and before that there was written language, rather recent, just 5,000 years. And then you look, oh my God, 50,000 years ago, first imprint of human beings, megafauna disappeared. Then you start going further, there was cave art, the ability to represent useless things such as symbols. Before that, there were weapons and tools, and before that, there was fire. So if I had a scale here, the tango between human brain changing the environment, and the environment in return changing human beings started long ago. And then there was almost a quantum jump when the language appeared around 5,000 years ago, and then things were out of the barn. Things developed massively, and here we are. So when we think that can AI destroy the world, where human intelligence has already provided substantial evidence that it can, and it does. So what can we do to develop AI that is from ground up moral, such as some of us, we believe, are moral. We are not out to destroy the world. So we need to look a little bit further than humans. Since this evolutionary history happened, are animals intelligent? Yes, actually, in terms of human intelligence, Coco, the female gorilla, could recognize 2,000 English words. Question becomes, were humans a million years ago, if I were to bring in one of these Homo sapien here, will that Homo sapien do better than gorillas or not? We can't do that experiment. Or maybe modern gorillas too are smarter. But I'm going to try to sell you a hypothesis, while those things are possible, that human technology changed humans, and vice versa. What's the fundamental difference? Many animals use tools, but humans not only use tools for food, they use tools to think and communicate. Try doing mathematics without paper and pencil, or try to geometry without drawing. Tools can change human body and brain too, and that's the part that we need to start thinking right now. While we are thinking, can AI harm the society, we need to start thinking, how is AI changing me? Me meaning all of us. So let's get into what goes on underneath the brain. Why does it change so quickly and so on? Well, in the brain you have neurons, and a fundamental property of neurons is that their membrane value is kind of between about tiny value, can jiggling around, and if it crosses some threshold, boom, it generates a spike. So neurons do digital computation. If it crosses a tiny threshold of a couple of millivolts, it amplifies it, otherwise it says it's all zero. That's why we think the brains are like computers. So neurons do digital computations. Small increase in membrane value by about 10% is amplified by tenfold, and then spikes are all or none. So let's think a little further. Why are we better or worse? Here's a brain, here's a computer. The most common thing you would hear is the reason we are so much better is because we have so many neurons, 10 raised to 11. What about computers? Well, your laptop beats it with your GPU off the chart, but your laptop cannot do a lot of things you can do. The clock speed of the brain, as you saw the action potentials, is 1 kilohertz. Your laptop runs at tens of gigahertz, so not really very fast, orders of magnitude slower, but highly energy efficient, 20 watts versus 20 kilowatts. massive cooling towers for AI. Another fact that I'm going to share, not spend much time on it, but whenever you measure any signal in the brain, the neuron's responses are highly variable. The mean value of the signal is more or less equal to standard deviation. We call them Poisson processes. Computers are highly reliable. So the summary is, can human intelligence have something to do with these four things? Our brain is slow, our brain is sloppy, our brain is sleepy. I hope all of you are falling asleep soon enough. And at the same time, it's highly efficient, orders of magnitude. So what about intelligence? Out of this, what can we say about intelligence? Well, there are two types of intelligences. One is called non-declarative intelligence. We all walk. If I ask you, how do you walk, you won't be able to tell. If we ride bicycles, and a tiny fly can beat us hollow. In that, you can't catch a fruit fly. It flies. So the brain is like way smaller than us. So non-declarative intelligence, where we don't know how we did it, don't need much. It's the other kind of declarative intelligence where there are shortcuts, abstraction, language, generalization. For that, there is a crucial part of the brain called hippocampus that's needed. Funny enough, when hippocampus gets damaged, you have Alzheimer's, epilepsy, learning and memory disabilities, depression, autism. It all kind of converges onto the tiny, just about that size part of the brain. It's supposed to be also the GPS system of the brain that got the Nobel Prize. And most people think, when they think of intelligence, this frontal part of the brain called prefrontal cortex, but they forget that this other part, which is the oldest part of the brain, not the new brain. Hippocampus is also called the old brain. So what's up with the oldest part of the brain doing all these amazing things that we want to do in machines? So hippocampus, here's the brain circuit, a very simplified version. This is where your eyes are. These are the first set of brain regions, which are kind of supposed to be boring. Then it goes through various things, and all the way at the top, you see this thing called HC, or hippocampus. And deep networks are modeled after that to some extent, because there are many layers. What people forget in deep networks is that it doesn't go forward. The hippocampus communicates back all the way up to the eyes through many layers. So let's listen to the activity of one neuron in hippocampus while animal is actually doing generalization. So you will hear for the first time, many of you, actual sound of a neuron, which is easy enough once you have the technology going, because it generates a 100 millivolt spike. It's pretty massive. So you'll see the activity of one neuron when the rat's running around, and you will see that, so here's a top-down view of a maze. That's a rendering of a mouse. That's how it spikes. That's how a neuron sounds. Very brief representation of what it's getting. And then we are going to speed it up. This mouse runs around in this maze. People are throwing food. He scratches himself. He falls asleep. He gets distracted. And still, despite doing all those things, that neuron is active at only one spot in the maze. And a different neuron is active at a different place. The mouse had never been to this weird maze until we, of course, built the maze for the first time. So he was not born with it. We can show that. So how did the mouse create a map of the world instantly, within few seconds? So we built a virtual reality system, because he could be just sniffing stuff on the ground, and that could be it. So we said, how do we test how we human beings create abstract representation from a bunch of cues on the wall to say where I'm in space, what's the distance, what's the angle, which are certain abstractions. So now rats have to navigate only using vision. They can't use their whiskers and their noses, which are very, very powerful. Rats can smell a landmine half a meter under the ground, so maybe it's just an artifact of that. And the cool thing is that now, with rats, we can listen into the single neurons, whereas with humans, we can ask cognitive report of what you did, which you cannot ask a rat. So what happens, first of all, can the rat actually generalize? And so this is virtual reality. He's held in one spot, like a horse running on a buggy. Wears a little vest, he's happy, and he's held in one place. These virtual pillars appear, and he has to go underneath it to get a reward. And what you can see is that remarkably, even though rats were never, ever made to find their way in the world using only vision, they're able to do that. able to go around, find the reward. He can even detect that he reached the edge of the table based on motion parallax. Even though his whiskers say he's in the same place, he's able to do that. So this is pretty exciting. We can make rats behave like humans, create generalization and abstraction of spatial maps, and create some invariant representation. And what came out were lots of results, but one interesting thing that came out shocked us. And I'm going to share only that one thing. So we let the rat run around in the real world with the same visual cues and virtual reality. And right now, so many people are putting on these goggles, costing anywhere from $500 to $3,000 to $4,000. In the real world, each ellipse is a different neuron, and lots of neurons are active. In virtual reality, seemingly identical experience, 60% of hippocampal neurons shut down. Now, this is a whopping effect on a part of the brain which is highly sensitive to epilepsy, Alzheimer's, you name it, dozens of diseases. When 60% of neurons shut down in part of the brain, doing something completely innocuous, such as to just walk around, we need to start thinking as an evidence of what will AI do to our brains, which is not much of a part of a conversation, and I want to bring it up, and I can give you more examples too about how that is. And I want to end with one more reason why brains are so much smarter despite being slower, sloppier, and noisier. So if you look inside the brain, this is about 1 millimeter by 100 micrometer. There are jam-packed neurons. And you might think, wow, that's impressive. But if you look closely, there is something funny going on. This is just one neuron, 2 neurons out of it. Each neuron has distinct shape. And people identify these neurons based on different shape. That one looks like bitufted, this looks like something else, and you have lots of examples of neurons. And it turns out that everything we know about how the brain computes is based on what happens here. That's about 10 micrometer, given this is 1 millimeter. That 10 micrometer region is what generates spikes. And we believe brain does computation with that, but we have no technological ability to know what's going on in the rest of the giant tree. Now let's start thinking somewhat from basic facts. If you put the numbers together, each transistor in a computer is 5 nanometers, 10 nanometers. A neuron with all that is more than 1 billion times bigger than a transistor. Now clearly, neuron has tiny holes that actually pass single atoms at a time. Why would then the brain create neurons which are so gigantic? Why will it make it so huge? You can say, okay, it's DNA and other stuff. All DNA and everything is packed just right in this. So why are neurons so gigantic? So we played around with some nanotechnology and so on. I had to say that in because we are in CNSI. And for the first time, doing some chopstick technique, we were able to measure what's going on inside one of these tiny branches. That's the limit. Nobody else can do anything better. So we held this little branch while the animal is walking around. And now that you have listened to a single real neuron, you're going to listen to one neuron in behaving animal, but not just a neuron, but a different part about which people don't know what goes on even in a brain slice, because the branch is so thin that you can't even poke it with it, it just dies. But the chopstick somehow does the job. So remember the sounds and the pattern you heard, and now listen to this. So that's the signal from that branch. This is the signal from the cell body. Nothing. Minuscule compared to what's going on there. And its voice is different, much more deeper voice. These subwoofers are not here, so otherwise you'll need a giant subwoofer to make your chest vibrate. It's gigantic and a different sound. And then when we looked at it, we found something even more surprising. So this is just about 1 second long data from that one branch. These are the spikes that occur, but notice the gigantic fluctuations. What you see in the dendrites is that they are actually computing in a different form. They are not digital computations. Unlike the cell body, where you have tiny fluctuations here and then gigantic spikes, the subthreshold fluctuations are actually 3 times bigger than the spike, and they're modulated. So the core algorithm of neural computation is that each neuron is a network that does hybrid analog and digital computation. And we need to start having a dialogue amongst us to figure out the core algorithm being different, what's the advantage. So let me conclude by a few things. That the Neuro-AI joint investigation is a fruitful direction for both. And we have started up this group. Those of you who are interested, feel free to sign up. We are going to have meetings, discussions, and hackathons, and maybe write some papers too. So by all means, take photos or whatever, or write to me. This can have many applications too, apart from understanding the basic function of how do we tick. Because as you saw, your brain does lots of things that you have no idea that it does. You can't hear those spikes even though you can see it. There are billions of spikes going on in your brain. Can be useful for diagnosis and treatment of disorders in a fundamental way. We can build more efficient AI. And the one direction that we are going after is that since brain is so efficient, maybe efficiency itself, which is a fundamental need for all animals, to conserve energy, that's why we are all getting fat these days, because we are not made to live in this world, that efficiency of the brain is the mechanism by which intelligence arises. That's why we made tools to find food and so on. We need to start thinking from this to figure out how we can build moral AI starting from ground up, such as human babies are made in that way. And then we start to really start thinking of how is AI actually changing our brains so that we are prepared besides worrying about how AI might destroy the world. So I'll stop here. Thank you.
Thank you so much. We're actually going to save questions for after both talks so we can ask both speakers questions at the same time. So next we have Terry.
Thank you all for coming. I think we all, a lot of us academics, we tend to stay mostly in our own departments and work on our disciplines. But AI is such a cross-disciplinary topic. It's really important that we all actually talk to each other and see all the different connections. There's no one field really that can really understand the impact of. Sorry, it's hers. Okay, is that better? Okay. Yes, of this field. So my task here, I was asked to sort of explain the mathematics of AI. And I also want to talk about how AI will change my own field of mathematics. And I have 20 minutes, so I have 10 minutes for each. This is not enough time to really do justice to either topic, but I'll try to give a very, very quick, non-technical overview of, firstly, what AI is mathematically, and secondly, how it can change at least my field. Okay, so in the early days of AI, in the 70s and so forth, people try to mimic human thinking as much as possible, encode the laws of logic, and try to really sort of do a top-down approach. And it never got really successful. It had some minor successes, but not a lot of the hopes kind of did not eventuate. So nowadays we have a much different approach, which is much more dominant, which is machine learning, where we don't really try to capture the high-level functions of intelligence, but we just kind of brute force using data, large amounts of data, to try to simulate tasks that humans can do, but by a very different means. So what is machine learning? It's, well, if you're a mathematician and you have non-mathematical friends, they will often send you things on Facebook or something like this, thinking that this is what you do for a living. So they'll get these puzzles like, okay, you have a sequence of numbers, 6, 14, 36, and 98. What is the next number in the sequence? As a very, very crude approximation, machine learning is sort of designed to answer these sort of questions. So one way you can think about this this problem is that you can encode these 4 data points. You can encode as what you can call training data. So the first number is 6, the second number is 14, the number is 36. So you can encode them as input-output pairs, and that's your data. And your problem is that if your input is 5, what is the output? Okay, so you have this data and then training data, and you want to extrapolate it to a new input. Okay, so you can plot this, okay, and so if you like, you make a scatter plot, and your data is this set of points. And so the way machine learning, quote unquote, would solve this problem is that, okay, I'm going to try to fit a curve to this data as best I can. Now there are many, in fact, there's infinitely many ways to fit curves to this data. So this is one thing, mathematicians get annoyed when they see these questions, because there's actually infinitely many answers. Some curves are kind of nicer than others, and some will fit better than others. Now, there's a lot of really important questions here. Okay, like what do you mean by a nice function? What do you mean by fit? And then how do you find the nice function that fits the best? And that's why we have machine learning is a huge, massive field with lots and lots of equations and papers. But a large fraction of machine learning, okay, so this type of paradigm is really what's called supervised learning. There's a couple other types of paradigms, but this is basically what machine learning does. Okay, and then once you have this curve, you think you have the right fit, you can plug in your input and you get the output. So in this case, the intended answer is 276. I won't explain why. That's not the point of this talk. But this is basically what machine learning, at least supervised machine learning, does. It just fits data and then extrapolates. It's not guaranteed to be the correct answer, but for many types of data which are sort of governed by reasonably predictable patterns, but maybe not obvious patterns, it tends to work remarkably well. Sometimes there are theoretical guarantees of accuracy, but not as many as we would like. Okay, so that is sort of supervised learning in a nutshell. The most basic example that you probably are all familiar with is linear regression, where the concept of a nice function is just a line. The way you measure fit is mean square error usually. And then there's the reason you do that is because then there are some very nice and fast algorithms from linear algebra to find the best fit. So linear regression works well when you have approximately linear relationships, and it works well if your data, your input, is kind of within the range of your training data. Like it's not very good when you want to extrapolate far beyond where your data is. But somehow the amazing miracle of modern machine learning algorithms is that you can train on or still very large but restrictive, sort of in some sense narrow data sets, and they can get surprising performance on inputs that look quite far from your existing data sets, at least when measured in sort of obvious metrics. Right. So in this example, the inputs and outputs were numbers, but there's no in mathematics there's anything that can be represented as a vector or some mathematical object can be subject to this paradigm. So your inputs can be images and your output can be text, and suddenly you're doing object recognition. So you have a whole bunch of training data of images labeled with what they are, and then you can feed it a new image, and even if the new image is not resembling very much the initial training data, sometimes if you have a sophisticated enough algorithm, they somehow learn what is the essential nature of a dog, okay, and they can identify this as a dog. But you can't just use linear functions now. You have to use much more complicated models, and so one very popular class of models are deep neural networks, which are inspired by the brain, as we saw in the previous talk, but but only as a very crude approximation. So there are huge networks of linear and nonlinear functions with lots and lots of parameters, and then and those are your nice functions. And then you have various ways of measuring fit. There's these various loss functions that measure to what extent these networks fit your training data. And then there are these clever algorithms called backpropagation and gradient descent to actually try to find which parameters fit your data. Well, and they work reasonably well, but you need lots and lots of compute to actually get reasonably good answers, and you need massive networks to get good performance. They're not the only models out there. So there are tons and tons of models which have nothing to do with human brains anymore. There's one called diffusion models, which is based on the laws of probability. So I can't talk about it in the time you have. But one thing they're good at is actually solving the reverse problem. So instead of labeling images, if you have text and you want to convert the text back into an image, with enough training, you use the same training data in reverse, you can actually now put in any prompt, any text prompt, and try to create some random image that kind of fits the prompt. So I actually did this, we're talking, this is a dog eating spaghetti using ChatGPT actually. All right. And you can, and then of course we had the large language models, and so they're basically the same task, but yeah, but what they're basically, the basic task that they learn is how to complete sentences. You take a partial fragment of a sentence and you train it with lots of data of what the next token or next word will be in a sentence, and remarkably, with enough data, they can really start giving reasonable answers to new sentences that they haven't seen before. That they somehow learn the structure of language, and while they don't have a deep understanding of meaning, they can somehow simulate it, at least superficially. Yeah, and so these are, I mean, that's by no means the only technology that goes into things like ChatGPT, but that is sort of the basic idea. But they mimic intelligence. They don't have high-level thinking, or if they do, only to a very, very weak degree. So famously, they hallucinate. They're trained to produce text that looks like it's correct, which for very simple types of queries that is enough. But anything that requires actual substance, it can often be like completely untied to any ground of reality. So it is a powerful tool, but still very limited in many ways. Sometimes it can be extremely impressive. So there's this famous paper, Sparks of AI, where they tested an early test of this of GPT-4, and they gave it a math problem from one of the International Mathematical Olympiads, a competition problem which the best high school students in the world, only a fraction of them solve it. And they tested on many hundreds of these questions, and there was one or two questions, like on 1% of the questions, they actually got almost a perfect answer. So this was quite a sophisticated math question for which GPT produced pretty much a perfect solution, just by completing the next word every time. And that's basically what they did. So that was stunning, except that it only works 1% of the time. And then conversely, you give it like really, really basic arithmetic problems. Okay, like you ask it to compute the sum, and it will give you the wrong answer. Because it just predicts what is the next token in a sentence, and it gives an answer that kind of, it knows it will guess a number, but it guesses the wrong number. In this particular case, it guessed the number, and then it paused, and then it said, oh, I should maybe explain where this answer came from. And so it did it step by step. And by step by step, it got to actually the correct answer, even though it initially stated the wrong answer. And then we queried, but you started, you claimed that it was 120. And I said, oh, that was a typo. Okay, the correct answer was this. So it is, they're amazing tools, but still quite limited. So, in mathematics, of course, we're famous for not tolerating even the slightest error and very pedantic about various things. We want 100% guarantees of proof. How could you possibly use a tool like this in this subject? So by itself, you really can't. But you can use it to do other things. They are somewhat useful in suggesting unexpected connections between different areas of mathematics. Or like if you want to solve a math problem, like for example, you want to model a fluid equation and you want some solution, you can train an AI on existing solutions, and it can kind of guess kind of solutions. But the point is that you can't take these solutions on trust. You have to verify them by other means. Like you can numerically verify that the solutions that the AI produce are somewhat accurate, or do some theoretical calculation. But in mathematics, this is one thing we are very good at. We are good at checking the answers. And sometimes the model itself is not so much the specific inputs and outputs that are interesting, but actually the particular model, like the choices of parameters that the model finds to solve a problem, sometimes you can analyze that, and that actually tells you more about the relationship between inputs and outputs than just sort of testing individual pairs. So one development I'm really excited about is that complementary to AI, there's this other technology in mathematics called proof assistance, where these are software that actually they were designed they came from engineering actually, because there was certain circuitry like for aircraft and so on, military applications, where they really want 100% guarantees that a certain circuit did exactly what it was told. A certain software was 100% bug-free. But the same languages that do that can also verify proofs. If you write a mathematical proof in this language, it will compile only if the proof is completely correct. And so it can give an automated way to completely check if something is actually a proof and not nonsense. And that's perfectly suited, at least in principle, for compensating for the worst weakness of these large language models, is that sometimes they produce a lot of nonsense. So if you ask it to solve a math problem, you can ask it to output the math problem in this form proof assistant. You then send the proof to the proof assistant, and if it compiles, great, it's actually solved the problem. If it doesn't, it gives feedback. And the large language model can adapt its output to try to actually make it compile again. And people have just started experimenting with this kind of paradigm. The current state of the art is that if you give it a problem which is kind of like an undergraduate math homework assignment, something that requires, say, 5 or 6 lines of computation, this iterative process of going through producing formal proofs that are verified and having a feedback loop, it can pretty much solve a lot of undergraduate homework questions. Which means, by the way, we're going to have to revamp the way we assess math homework, but that's a whole separate topic. But it doesn't work. I mean, if you send it any complex task, any really complicated math task, just this sort of trial and error, it's very similar to having an undergraduate keep guessing answers on the blackboard in office hours, and just hoping to get lucky. It works up to a point and then it stops working. We need some more ideas to sort of upscale it. But what this does mean is that it means that formalization is going to be a lot easier. So these formal proof assistants are really annoying to use right now. I run several formal proof projects now, and it takes I estimate about 20 times longer to write a proof formally than it does to write it in sort of standard English using LaTeX, which is our standard editor. A lot of it is because there's a lot of tiny steps that in a human written paper, we say clearly this is true. Because A and B is true, C is true, and every mathematician reading it, or many of them, will say, oh yeah, I see that. But then you actually want to formalize it, and you realize that this one step, this is obvious, actually becomes 10 lines of code, and you have to find these 10 lines of code. But these are the steps where these AI paradigm, these large language models could automate for us. And maybe in the future, we could actually I could envision a future where the way mathematicians would write papers is that we would explain our arguments to GPT, and GPT will, in real time, work out, the formal proof and also a nicely teched up version of your argument. If there's a problem, it will try to solve it. If it can't understand one of our steps, it will either try to solve it itself, and then if not, it will come back to us and say, I didn't understand this step. Can you explain this further? And then at the end of our conversation, we say, if it's satisfied, okay, I understand your argument. Here is the paper. Here is the formal proof, and here's the button to submit it. That'd be great. And also, this proof, once you have enough formal proofs, that itself is a useful data set. You can train, and you can say, oh, this argument resembles this other argument. Maybe you should look at this other paper, and maybe this argument has some applications to this other area of science and so forth. So there's a lot of potential to really change the way we do mathematics. Mathematics has not changed. In many ways, it has changed a lot slower than other disciplines. The way we prove theorems and so forth is very similar to the way we've done it 100 years ago, 200 years ago. For instance, we still only collaborate with at most, so 50 years ago, in fact, most papers were single author. Thanks to the internet and email and so forth, and the fact that math is becoming more interdisciplinary, we've maybe gone up to like 3 to 5 co-authors in a project. It's hard to get much further than that, because in math, if a single person contributes a single, some part of the argument with a single error, the whole thing can collapse. So you need to really trust all your co-authors and verify. And so past about 5 people, this becomes very difficult. Yeah, but for example, when I do formalization projects, it routinely uses 20, 50 people. You can take a big project to formalize a massive proof. You break it up into tiny steps. Each step is one formal task, and it's just someone random can just pick up that one little piece. They don't need to understand the whole project. There's a very well-defined goal that you need to supply 10 lines of code to get from A to B. And they upload it to GitHub, and GitHub automatically verifies, yes, this compiles, and then you can accept it. And so formalization opens up ways to do big mathematics in the way that other sciences do big science. But again, the user base currently, these languages are still so annoying to use that we don't, only like 1% of actual mathematicians, research mathematicians actually use the software right now, I would say. But with AI, it would become a lot easier. And this ratio of 20, as I said, where it takes 20 times longer to formalize a proof than to write it by hand, this ratio will go down. And with AI, I see no reason why it can't go below 1. Eventually, it will be faster to reach a correct proof using AI-assisted formal proof assistance than to write it out longhand. And that will change the way we do mathematics. Then we can do some really massive collaborations. We can involve the general public in math projects in a way that we don't right now. So I'm really excited about the potential in math, at least. Yeah, and there's just beginning to be some nice experiments. Still, it'll be a few years before it really transforms the field, but it's coming. Okay, I think that is all I wanted to say.
Thank you both so much for great talks. We have time for questions for either speaker, and if you're online, please use the VVox link to ask questions there. If you're in the room and you have a question, you can go old school and just raise your hand.
We have mics to bring.
So, would AI figure out Pythagorean paradigm? It just comes out from AI, or I mean, I'm nowhere close to AI, but that's what I think AI could do, right?
I'm not familiar with. I'm not sure what you mean by the Pythagorean paradigm. I mean, there are hopes that you can use AI to formulate new conjectures and maybe make new connections between different areas of mathematics. So far, there hasn't been really great successes on that front. As I said, the successes are quite small scale currently. They can solve, as I said, like undergraduate level problems. I mean, they're very data driven, so you need, so the closer that a problem is to something for which they have a lot of data on already, the better it's behaved. I think for many years, if to like really conceptual high level mathematics, really would still be a mostly human directed endeavor. But we can use the AI to automate a lot of tedious checking, and there's a lot of tedious stuff to do in mathematics, and I would love to have AI assistance in that. So it's not a magic wand. It does certain tasks very well, and other tasks it's terrible.
So do you have any comments about the recent alpha geometry that they can solve the Olympia level of geometry problems?
Yeah, so that was a very nice piece of work. So there's this challenge. So the Math Olympiad problems, there's this competition, international competition for high school students. It is a very natural challenge to get AI that can solve these problems in general. And so there's one specific class of problems that is very structured, these geometry problems where you have a whole bunch of points and triangles and circles, and you make certain hypotheses that this side has the same length as this side and so forth, and you want to prove some other conclusion. It turns out that particular type of problem is a very restricted class of problem that you can almost solve automatically without even AI. It's basically trying to solve, to show whether a whole bunch of equations apply another equation. And there's a branch of algebra that is devoted to proving just that. The problem is that the existing algorithms are just a bit too slow. Like once you have like 10, 20 points, the time complexity grows exponentially. But the way that, but what often helps is that if you make an inspired construction, like sometimes you have a collection of points, if you can add one more point, like the midpoint of a line segment or something, and you figure out how that point relates to all your previous points, with just one or two constructions, you can massively simplify the problem. And you can create all these additional relations, and then you plug it into a traditional algebra package, and then you can solve the problem. And so what alpha geometry did was that they trained an AI to somehow discover what are the right constructions, what is the few extra points to add. And they also created a huge database of synthetic problems to train on. That was another nice feature. It is a nice paradigm. It doesn't extend very well beyond that specific use case. I actually had some discussions recently about some other problems that are of that type where there is already some automated way to solve the problem, but you just need one or two clever inputs. And so for things like that, this alpha geometry approach is very useful. But most mathematical challenges are not like that. It's not just you need to add one more step and then everything becomes easy. Typically what you need to do is you need to take a difficult problem and break it up into like 3 smaller pieces that you think are easier to prove and are still true. And together they can combine to prove the more difficult thing. This kind of high-level strategic thinking, we haven't yet figured out how to get AI to do that. I think that will still be mostly humans for a while.
Thanks. I submitted the question online as well, but I guess I'll just say, there's kind of a classic webcomic describing the math of machine learning as a pile of linear algebra that you stir until it looks nice. And I'm curious to what extent do you agree with that? Or are there any sort of like pure mathematical concepts in something like a neural net that are sort of like mathematically interesting? Or yeah, any thoughts on that?
Yeah, there's a lot we don't understand about why neural nets, I mean, these phase transitions where these neural nets, they perform very badly, and then you pass a certain threshold of data and parameters, and suddenly they become very, very good. And suddenly they can, I mean, it's not so surprising that they work well within sort of the same type of inputs that your training data set gives, but what is amazing is sometimes they're further. It's still, the theory is lagging well behind. So like, yeah, we have some theory on how to make the training converge and how to accelerate it and so forth. Yeah, what we really don't understand is why it works as well as it does, and like what is the feature of the data. Like, we kind of have some idea that there's some low-dimensional structures inside data sets that are not obvious, and with the right architectures, they can locate them. But it is a remarkably empirical side of mathematics right now. Yeah, no, I'd say the theory is decades behind the practice at this point.
We have a question.
There's another one.
Thank you very much for being here and for the lectures today. As you show, AI is all based on the training database, and it's a predicted model that tries to predict what is the next word in this case, or the next number. And all the training is done with human brains or human-generated outputs, right? So we use all the internet and all the data that was produced by humans to train the database. Going forward, is there any risk? And I think there's some papers around that because the future training or whatever continuously informed now the training database is AI-generated data, will that cause any problem?
Yeah, we are running out. Yeah, so yeah, this is incipient problem of data pollution. I'm not. Yeah, so I think we have almost exhausted. I mean, we're going to have to either really come up with really novel types of data. For example, in mathematics, AIs are trained on mathematical output. So there are lots of available preprints of math papers, and there's Wikipedia and so forth. But there's not much data on the actual math process. People have not attached cameras to grad students and to see them how they actually learn mathematics. Maybe we should. There's a limit to how much we can do with the data we have, and there is a danger of a feedback loop that the more data on the internet is AI generated, the less useful it is for training. I think already language translation is already beginning to suffer from this problem. I think that because a lot of translated texts are on the internet are created by Google Translate, they're useless for Google Translate to help improve their algorithm further. So there's a lot of research on how to clean up data sets and compensate for bias and create synthetic data sets that are better. I think the big breakthrough would be figure out how to learn with less data. I mean, as Mayank's talk said, these algorithms are incredibly inefficient in how they use massive amounts of data to get a small amount of inferences, and humans don't need that. They can generalize from small amounts of data, and we haven't figured out how that works. I think the better thing to do is to try to find more lightweight ways to train, but that's a future challenge.
I have a question from the chat for Dr. Mehta, which is, can you say more about the hypothesis that AI will have an effect on the human brain?
Yeah, actually, if you don't mind, I want to add to the previous question as well. So there is a paper that just came out last week in Science where they did a dramatically different kind of AI, which is that they attached a camera to the body of an infant, a child about 1 year old, and a microphone. And then whatever was the stimuli that were coming in to the child, mother saying something or the other, they trained a small network to do, basically just learn that. And we all know that we as human beings, we current modern human beings as infants, we do generalization quite readily, right? I mean, I taught my nephew one of the days to say, here is a flashlight. And then we went out for a walk, and the nephew saw a water tower and said, flashlight. So clear wrong, but generalization. And this simple thing, starting with some simple concepts, was able to do one-shot generalization, which is sort of the holy grail. So it's a paper in Science. I can send you references. So there is that possible. And if I may draw a connection with what we did many years ago, predictive coding is a major goal in many of the things we want to do. Like you mentioned, you pull up a sentence and you want to basically predict what's the next word or something. And what we showed is that actually, unlike the claim of Minsky and Papert, which say that perceptrons are pretty much useless, they can only bisect a plane, if you put a little bit of biological learning algorithm, which is different and will take a long time to go through, it can actually learn to do predictive coding on the fly, rather reliably, just a perceptron. So there is a way to go quite forward by incorporating simple ideas from biology. The learning algorithm in biology is not supervised learning at all. It's entirely something else called Hebbian learning or something else. So that's something I can add to that. And then in terms of the other question somebody asked, how can AI change us? Well, I can give you many examples. This sounds something for most of us because we are so based on our mind, and we are unable to actually introspect about our brain because we have no access to our brain. So I can show you many examples where I can change your brain permanently in 5 seconds. And maybe later on I'll show you examples like that. So I cannot guess how AI will change my mind, change my brain. I can guess what AI might do to my mind to say, oh, well, if I started to use calculator all the time, then my ability to do arithmetic went down, which is true. I used to multiply all sorts of numbers, and now I'm no good at multiplying in my head. But this is something else where you cannot introspect. Because there's something weird things are going on in the brain, and 99% we don't even know what the hell is going on. I tried to give you some examples of very low-level stuff that we found. So bottom line is that we need to start thinking from the point of view that brain is something to which we have zero access to what it does. Unlike your heart that you can listen to and maybe your stomach that grumbles, your brain, you have zero idea. So we need to start thinking differently, and that needs to be a dialogue between people who write algorithms and people who look at the brain.
I have a question about your favorite proof checkers. So I know about the project where they try to use the lean checker to verify Fermat's theorem. I prefer the Coq checker for the kind of things I do in linear algebra. What do you prefer?
Okay, well, I mean, I'm mostly familiar with lean. I think Coq has some technical advantages. It was an older language, and it is more efficient in some ways. The thing I like about lean is not so much the language itself, but the community. There is there's, for example, this collaborative project, massive collaborative project to sort of formalize all of sort of undergraduate level mathematics in this math library. And it's a very cumulative project, and every project that builds upon it is encouraged to contribute its theorems to this library. And I think over time, that is maybe the more promising approach, to have a whole sort of network of existing theorems that they all cite each other and so forth. I think with Coq, you often still have to prove things sort of from scratch very often. And so while it sort of has advantages currently, I think the collaborative culture of lean is a good thing. Of course, there's not preventing Coq from doing something similar, I think. But yeah, in the future, I hope also that AI will allow translation from one formal language to another. That's something which is still very difficult right now. But this feels like a solvable problem with AI.
Hi, so I'm a mathematician, but I have a question for Professor Mehta. So I understand that you can only get one of these fibers going into a neuron at the moment and measure it. So my question is, if you were able to get several of them, what would you be looking for?
Yeah, that is absolutely the question. And the technology, thanks to a president, Obama, who put in $1 billion into Brain Initiative to say, let these biologists have the technology to measure the activity of many neurons and many fibers at the same time. That has just started to become available. And now people, especially mathematicians, have a huge role to play here. So I wrote to Terry a couple of examples that we are dealing with. People are looking at how, first thing people found is that the dimensionality in which the neural activity lives is extremely low dimensional representation, right? The number of things that I can do consciously or unconsciously, I don't know, billion things, that will be tops. And we have 100 billion neurons and 1,000 trillion synapses. So what's up with that? So people have found that the activity of neurons lives in a very low dimensional representation. So people are trying to figure out, is there a topology in that space of neural activity? If there is topology, is there geometry? Is there a concept of distance? And how, and we are spending a lot of time in this, trying to figure out how is that low dimensional representation achieved. We're trying to imagine the possibility that the reason neural activity is so noisy, where standard deviation is almost always proportional to the mean, is to increase the Bayesian of attraction, which allows generalization. So we might actually be able to come up with ideas of what are the things that we are good at generalizing, and what are the things that we are hopeless at generalizing. And that's hard for us to imagine, but we can see a fly is very good at navigating through a bunch of leaves, no problem, but the fly can never figure out that's a piece of glass. They keep banging the head. So that thing doesn't work. So we have similar weaknesses. That's what we want to go after. So this has just become available to scientists to go after that.
That was a wonderful answer. Thank you.
Thank you.
So a lot of the advances in machine learning have been pushed by some of the benchmarks like in vision or in natural language processing. Could you comment on the benchmarks in math and where you expect it to take the field?
That's actually one of the challenges, is that we don't have, okay, so there's some sort of obvious benchmarks, okay? So if ChatGPT manages to get a paper in the Annals of Mathematics, which is our top journal, okay, that would be a benchmark, okay. There is some recent thing called the AIMO Challenge, Artificial Intelligence Mathematical Olympiad Challenge, so Artificial International Mathematical Olympiad Challenge, where AI will be given the test problems for the IMO at the same time as the human contestants, these human high school students, and at the same amount of time and access to a certain amount of compute. And I think if they can get a gold medal, they'll be judged by human judges. They'll try to make it as similar as possible to the human experience. If they get a gold medal, there's a $10 million prize for that. So that's one benchmark. Yeah, we don't have standard challenge problems yet in mathematics. There are other machine learning challenges where the precise benchmark was actually very useful. I'm familiar, for example, there was something called the Netflix prize about 10, 15 years ago, where Netflix had this problem. There was this data set of customers who rated certain movies that they watched, and they wanted to predict what other movies would they like based on the movies they already had. And this was a machine learning problem. And there was a very high-profile prize that actually advanced the field a fair bit. Yeah, so we could do with some more precise technical challenges, actually. They may not be specifically the most urgent problems in mathematics, but you want something that's sort of replicatable and standardized, and you can see year on year there's a 5% improvement, 10% improvement. Yeah, that is something very important.
Maybe just to sort of follow up on this question, so I think the question was really about... Okay,
Please come.
Thanks. I think, so the questions often are, how well will machine learning do, or AI do, in replicating human thought, or a system of mathematics that's invented by humans? But the more troubling, the more troubling thought is, will AI generate systems that are completely impervious to us, and have enormous impact on the world, such that create a world of thought that is not penetrable to humans?
Yeah, I think that's something we really need to think about, right? So the way the current AI has gone is basically large language models focusing on language, barring few examples that I mentioned, which is also based on language. Mother talks to the infant, which is still based on language, but we clearly know that the language areas in the brain, there are just two, called Broca's area and Wernicke's area. Each one is about that big. The rest of the brain is not language area at all, and it's there in all species. So what has happened is that because of the success of predictive coding, essentially with more and more parameters, we have gone down the path of one kind of language-based thoughts. And in the process, we have created a beast. God knows what's going on inside, and God knows what's going on inside the beast that we are carrying in our skulls as well. So what's necessary is to start using, in order to address those questions, which is very valid, to say, how will that complicated beast interact with our complicated beast? We don't know that. We just showed you just walking in VI can change the brain, so virtual reality can change so massively. So clearly that's a valid reason. So the way to go after is that sometimes when we get very familiar with few things, such as what's going on in our mind, not the brain, we need to start doing things like you were mentioning, to say, let's take the activity of, God knows, 200 neurons, which is already very high dimensional space. And there's some simple task. What actually went underneath the hood? Can we start getting a sense of what's that algorithm and how is that getting influenced by simplest of things? And that can give us an idea of how that complicated beast with trillion parameters might be doing something. And there are very deep questions that come about to say, is there, like Terry referred to, is there a phase transition that you go for 100 neurons or 100 parameters, it can't do something, and for all of a sudden, like 200, it can do something, or add some more zeros. And there is evidence in neural networks that there are such phase transitions that, as you referred to, so we need to start looking into such things. And I'll add just one more thing. Unlike anything else in human body, where each cell connects to only 12 cells, brain is the only organ where each neuron connects to 40,000 inputs. So there is something about 40,000. Make it 50,000, make it 20,000, but more or less, the magic number in the brain is about 50,000. What's up with 50,000? So I would love to answer that question. Why has the brain converged on 50,000 across species all over the place? So, please.
I'll have a separate answer to your question about what's the danger of AI producing these very opaque answers. So you should think of AI tools not as the end of the story, but just as the first step to understanding. So an analogy might be with calculators. Okay, so in the past we would do everything by hand, and then suddenly there's these calculators, and we don't, most people don't understand the algorithms that make these calculators work. And so you can punch in numbers and you get our answers, but you have no understanding of how the calculator got the output from the input. But once you have the calculator, you can play with it. Kids who are interested in mathematics, they will just punch in. What happens if you multiply 1.11 by itself many times, and you get all these patterns? And you can discover new mathematical relations because you have this new tool. There was a recent result in knot theory where people were trying to see if a whole bunch of what are called knot invariants could predict a further knot invariant. And that they attacked it with a massive neural network. And the neural network found a relation between these statistics that weren't previously known to be related. But it was very opaque. It was a very complicated neural network that could make this prediction. But what they could do is that once they had this model, they could tweak the parameters. They said, well, what if I change this statistic, this input statistic? How much does each statistic input change the output? Just like a kid would play with a calculator. And what they found is that of the 20 input statistics, only 3 of them actually had a significant impact on the prediction. And then but it was not 3 that were obvious suspects for being the most important statistics to play with. So the neural network gave this really important clue as to which features of the knot to focus on. And then with those sort of clues, they were actually able to find a theoretical explanation of this prediction. So it's going to be an interplay between, mathematicians have to be more like scientists, where with these AI tools can give you experimental verification that certain things are true, but you still want to get the understanding, and that will require more scientific experimentation.
Sorry to take 30 more seconds. So you mentioned very nice examples, which we all know that this AI generates hallucinations. Now, first thing, they are not hallucinations, those are confabulations. So let's keep the words separate, people call it. But the reason I came to that is that sometimes when I was an undergrad, I confabulated, I didn't know the answer and I made up something. But our mind is constantly hallucinating, constantly. Those are called thoughts. We are creating all kinds of things, phantasmal things, even when we fall asleep. Our brain has the desire to create those hallucinations, even more phantasmal ones. We need to start looking at those things. Once again, as you mentioned, when you have lots of neurons, the thought has a tiny access to all those hallucinations that are going on. Clearly it's playing a role. AI has none of those real hallucinations. It has few confabulations.
So I'll ask one more question from the chat, which is, how may we apply these AI mathematical concepts to the general public?
I'm not quite sure what you mean by applying AI to the general public. I can speak for my field. We don't do much citizen mathematics. So there's citizen science in other areas. Astronomers, amateur astronomers can find comets. Amateur field biologists can find butterflies, new species, and so forth. In mathematics, we've not been able to utilize the amateur. There's a lot of math enthusiasts who are not formal research mathematicians. It's because there's a lot of technical barriers. A lot of the work we do is very technical. And as I said, we have to be 100% correct. And we can't just verify streams of low-quality mathematical input. But maybe with AI, this becomes possible. I think it will enable sort of democratization of science in general. You know, I already use AI tools routinely. If I want to learn some topic in chemistry or you know, or quantum physics or something I'm not really an expert in, you know, in the past I would use Wikipedia and Google and so forth. I still do that, but AI also enables me to sort of readily learn more about other fields. So I think that's one place in which, I mean, in the future, every member of the public can have an AI assistant that can explain to them really complicated topics in science, you know, in hopefully without the confabulations. I think that would be fantastic. So that I think is one of the biggest positives.
Thank you so much for great discussion, great questions. We're going to go to a break. Please come back at 11 for a panel on AI and research. And thank you so much to Terry and Meta again. Welcome back from the break. Just a reminder, there is no food or drink allowed in the auditorium. Oh. Except for water, and the panelists can get away with it. So next we have a panel on AI and research. This will be hosted by Eliezer Esken. He's a department chair and professor of computational medicine and also our interim director of DataX. So thank you again.
Okay, great. Thank you very much. So today we have 3 of my distinguished colleagues who use AI in their research, and you know, the goal, you know, the scope of this panel is quite ambitious, right? But I think what's most, you know, if you look at, there's so much that's said in terms of generalities about AI and how it's going to change the world and affect every field. I think what's most instructive is to really look at kind of researchers who are really at the top of their field and how they're specifically using AI in their research and kind of specific examples. And so that's what I'm hoping we will get today. Okay, so first I'd like to introduce Lola and have her start.
Okay, hi everyone, can you hear me? Okay. So my name is Lola Oknyemi, and I'm a biomedical informatician and a writer, and I'm really interested in how telehealth and AI can be used to improve access to care in medically underserved settings. So a lot of my research focuses on that. I'm currently interim vice president for research at Charles Drew University and a professor in the Department of Preventive and Social Medicine there, and an adjunct professor in the Medical and Imaging Informatics group at UCLA.
Oh, okay. Introduction, or do you want? We just go straight into your 8 minutes. Yeah.
Can go straight Oh, okay. Okay.
Yeah.
So I really got interested in looking at ways in which AI can be used in medically underserved settings, and moved to CDU from Brigham and Women's Hospital in 2007. And one of the first projects I worked on, Charles Drew works with a lot of safety net healthcare. So is everybody familiar with the healthcare safety net? Maybe I should define that. Okay, so I see some no's, some yeses. So essentially, you have clinics and hospitals that provide care to people regardless of their ability to pay, regardless of their insurance status, regardless of their immigration status, and so on. So Charles Drew does a lot of work with clinics like that. And so these are not your academic medical centers, right? And these are often the settings that need the most input from academic medical centers. And so one of the things that, one of the first projects I worked on, in one of my colleagues was the medical director of the THE Clinic to Help Everyone, which is a federally qualified health center in South LA, and had a patient with diabetes. And long story short, he was managing this patient. The primary care setting, folks can go to the federally qualified health center, but for specialty care, ophthalmology care, patients have to go to the county, which has no connection with the primary care clinic. And that's what patients had to navigate at the time. And he had a patient with diabetes. People with diabetes are susceptible to a complication called diabetic retinopathy. If it's caught early, no problem. You get laser photocoagulation therapy, you're fine. If it's not, you go blind. It's the leading cause of blindness in adults between the ages of 20 and 74 in the US. Long story short, he got his patient on the waiting list to see an ophthalmologist, and the patient went blind while waiting. So that got us started on several projects. The first was a telehealth project, putting cameras in the clinics so that ophthalmologists who are not based in South LA could review those patient cases and flag them as being at risk for retinopathy if they were, and first in line to get treatment. So we worked out a deal with the County of Los Angeles to do that. Anybody with moderate or worse retinopathy got seen within 3 weeks. So the patient who went blind waited 6 months and was still waiting when he got blind. 3 weeks, 6 months is a big difference. One of the things that we discovered is that a lot of patients still didn't come in. And we didn't have retinal images for those patients. So you may have heard there's studies from Google and other places where they have really great machine learning results on retinal images. Well, if you don't have images and you're trying to predict whether somebody has retinopathy, you go to the EHR and you try to do your best. It's not gonna be as good as a retinal image, but what we found was that we could predict with some success who had retinopathy, was sitting at home and thought they were fine, because unfortunately, it's asymptomatic for most people, so they don't know they're in trouble. So that's basically one of the ways. So working with the County of Los Angeles, we did an outreach to about 30,000 patients who during the COVID era were not able to get screened because the clinics were shut because of COVID. And the machine learning identified about 7,500 as being at high risk, and we essentially used machine learning to drive the intervention to get them in to get screened. Long story short. Hope that wasn't too long-winded.
Hi, everyone. So my name is Keith Chen. Brief kind of introduction. I'm a behavioral economist, which means that I kind of work at the intersection of kind of market design, economics, and kind of human psychology. I'm a professor at the business school. And like many business school professors here, I kind of spend part of my time in academia, and then periodically kind of I also spend a lot of my time kind of outside of academia. I was also the kind of founding head of economics and market design for Uber, for example, so a lot of my research kind of leverages this idea that we're kind of both interested in how kind of AI tools, as they propagate, both how we can use them as social scientists to kind of as a new tool for understanding kind of human behavior and the impacts of economic policy, and also like how these tools are being integrated and shaping the way that that firms interact with us. So I'll give you kind of two examples of that kind of from some work that me and my graduate students are doing. So one, many of you probably know, like, this is an audience that's going to be extremely familiar with kind of like the bounds of AI and kind of what we're doing. Many people here are kind of advanced kind of computer vision researchers. One of the things that we're getting very, very good at modeling is human visual attention. Okay, and maybe that's not like a surprise, right? The like kind of bottom-up human visual attention is very similar in structure computed to like in the way that it's computed to like our computer models. So we're getting very good at like showing an AI an image, and that AI can do effectively as good as like interpersonally, like using other humans to judge, like within the first few seconds, like where is the eye drawn to? Like what do you see on this? What is effectively invisible to humans, and what do they focus on like visually? What can they see? Okay, well, why is this interesting? Because a lot of firms now are very, very interested in this technology, and for a long time, like an increasing share of our interactions with firms out there in the economy happen digitally. So think about like, I mean, if you're anything like my household, the stack of Amazon boxes in front of my house every morning is, obscures the front door, right? It's like, it's extreme. So we have questions like, there's increasing statistics, 98% of kind of purchases happen through the buy box, right? That kind of one box on Amazon. And it turns out you can establish, both through some of these tools and through kind of human trials, that like that buy box has become more and more visually salient relative to like, see other sellers who might, offer lower prices or different shipping options kind of like down below. Okay, so one of my graduate students is really interested in, as for example, some of these tools propagate out, first of all, using these tools to kind of quantify, in some sense, the rules of the game by which us as consumers and kind of digital tech firms kind of increasingly interact. Okay, like, tech firms call this traffic shaping. How much can they do, right? Like, how much higher of a price can they charge in equilibrium by allowing kind of, by kind of digitally traffic shaping what we see and what we focus on, and how much can they shape in some sense our digital interactions? What are the limitations of that? That's one project. I'll briefly mention kind of a second project. A bunch of my research also focuses on kind of criminal justice. And one thing that, like, as economists, we've always been kind of focused on historically is just studying kind of decisions, right? Like kind of, we typically kind of focus on people's choices, and then we have a whole kind of history of intellectual machinery of just kind of backing out from that, things that we typically call preferences. But then we do policy, we do welfare with all of that kind of stuff. What we've been less good about is thinking about the intermediate processes, right? So how do people perceive the environment around them, right? What do people believe about kind of important economic variables? And we realize that that's becoming increasingly important. Many of you probably know, despite record-breaking economic numbers on every dimension, like, record low unemployment, record, growth, like, we come roaring out of the economy, tremendous numbers of Americans report they just feel terrible about the economy, right? And we've never really had tools for kind of exploring these kind of perception, kind of economic reality gaps before and trying to understand the causes of that. So let me give you an example of like one work that we've been doing lately with a graduate student of mine, Yilin Zhou, is we've taken like every Google Street View image in the United States, all right, and just asked, we actually have very accurate crime data for most US American cities. Let's just, for each of these images, as a left-hand side variable, code up like how many murders happened within 100 meters of this picture in the last 5 years. How good of a job can an AI do just looking at a Google Street View of predicting that? Okay, it turns out pretty well. Okay, and that's a little bit scary because there's some things about the built environment that highly predict crime. And then the other thing we can do, all right, maybe this is not a surprise to people. The other thing that we can do is do the same thing, but for people's perceptions of safety rather than actual crime. Okay, now we're kind of interested in asking, right, using the AI. Using these two kind of trained AI models, like what are the drivers of the wedge between both perception and actual kind of experience safety in certain areas, okay? Now, you can go even further and you can say this, right? So for example, many of you who are kind of familiar with analysis, why not just run regressions, right? So for example, suppose I want to know if I, wipe off graffiti, or if I pick up trash, right, or if I plant trees, how much more do people perceive that streetscape as being safe? Well, I could just run a regression, right? I could say I've got a whole bunch of images, I've trained up on human data of perceptions of safety. Let me just count green pixels in the picture, and then just run the regression. Pictures that have more green pixels, like like how much safer do people find them? How much actual less crime is there in that on those streets? Problem is like classic omitted variable bias, right? Like streets that have more trees also have nicer houses, also have kind of, that tends to be more in residential areas than in kind of commercial areas, You're going to get, in some sense, the gradient in the world, not anything close to the kind of the causal gradient. Okay, but now we can use generative AI. Let's take exactly the same streetscapes, okay, but let's like digitally remove trash, or digitally add trash, or digitally remove trees, or digitally add trees, right? Now we actually have causal estimation on the perceptual, on the perception of safety, right? I can say literally, now I can ask the AI, right? If I remove the, which gets like, extremely high R-squareds on people's perceived safety, like as I engage in these like systematic changes, like how do people's perceptions of safety change? And what we're most interested in is causal estimation on things which move people's perceptions of safety, but which in the actual crime data are basically level sets of actual crime. Right? So it turns out, people find well, okay, we'll leave more. There's a lot more that we can dig into that, but like I just wanted to give you an example of kind of, in some sense, it's beginning to allow us to kind of unpack perceptual, with causal estimation, kind of perceptual features of people's understanding of crime, important economic variables, digital experiences in ways that we've never been able to do before. I think it's an exciting time for social science.
Keith, if I could ask you a question.
Sure.
So trees, you were saying you could add it what is the effect of trees on people's crime? I'm just
Okay,
incredibly curious. Yeah.
Yeah. So
Yeah.
it's extremely powerful when you add trees. Okay, like you move from something. Say like add 2 trees to a scene. Depends a little bit on what kind of trees. Like people really like palm trees, it turns out, right? We all live in LA. We kind of understand, the bucolic image that people get in this. But you add 2 trees to a scene, which say increases the number of green pixels in the image by, like, say 30%. You can move from basic, in terms of people's perceptions of safety, you can move from effectively like the 80th percentile of safety from the 20th percentile of safety to the 80th percentile of safety just by adding 2 trees. Okay, which may be advice to kind of cities, right? Like if you want to make people feel much safer post-pandemic about going downtown again to to kind of these kind of commercial districts. So those are the kinds of things that you can find. And then the interesting question is, this gives us causal estimation on perceptions. It's not necessarily yet, and you can probably all kind of understand why, that if you plant trees, you actually reduce crime in those areas. But we also have some tools for trying to get at that, and we can talk about that more later. Yeah.
Oh, okay. So my name is Wei Wang. I'm a professor in computer science and computational medicine here. So actually, Eliezer is one of my department chairs. So my main area is really doing on the foundational side of AI data science, but I also do quite a bit of interdisciplinary research, right? Really, a more applied side of AI. So we have, I'm also the director of a Scalable Analytics Institute in engineering school. So I have a lab there in Boulder Hall. We have a large group of student postdocs. So I just want to briefly mention, some of our recent projects actually, that have not been covered by these 2 colleagues. So one of them, probably everybody knows, is like, large language model, right? So everybody used it or heard it at least, right? Many of you maybe already used it, tried it a little bit, right? Because it's very easy to just, open the browser and then type in a few questions, right? And play with it, right? So, but now the question is like, probably you heard it in news many times, like people are so excited about that, and why, right? So why should we care about this? And not because actually I'm doing research on that, but because actually I see there's a opportunity that AI models like that could possibly revolutionize everything that we've seen. Right, so if not quite yet. So give you some examples, like last year, actually, when the LLM just came out, right? So instead of just using it as like help us to polish our, writing, right? Emails and papers and the proposals, but actually, we, together with my student, we systematically evaluate its ability to problem solving, right? So we took all the midterm and the final exam of the undergraduate class at UCLA from different disciplines like math, physics, computer science, chemistry, biology, and we just took those exam questions and provided it to the ChatGPT. Right? Actually, ChatGPT is one of the models we evaluate. We also evaluate quite a few other models, both the open source one and closed source. So, and then just to see how well it, the LLM can answer those questions. It turned out to be, well, how do you compare it? Like on average, they got for UCLA, final exam, it's about 40 to 50% correct, without any training. This is just, without even like some in-contact learning or prompting. So it's like completely out of the box, right? The pre-trained model. So it's if you think that's good or bad, right? Well, it's good in the sense that actually, if I didn't take those classes, I probably wouldn't answer that many questions correctly, right? So, and then, but it's not good enough for us to actually use it to as a gold standard. Say, okay, ask LLM and then trust the answer, right? It's not good enough, right? So, and if you dig into that to see, where it tend to make mistake, right? So actually, it has amazing ability to predict what's coming out the next. If you want to predict what's the next word, right, in a long document, its accuracy is pretty good. But if you say, well, here's a question like from maybe a math class, right, about geometry, right? There's even with a figure drawing all those, very, very pretty chart, and then ask some questions, and then the LLM may not get it right, because its ability to comprehend mathematical concept without additional help, okay, is still not as good as we hope for. And we also tried like calculus, right? So we can see that sometimes when it does integral, right? So it's just getting number wrong. So all those kind of examples. We also have plenty of examples like in physics, like in biology. It's just got it wrong, especially when it's involved like multimodal data. Like you have like text, like equations, figures, chart, tables, all together there, right? Which is what we typically see in the final exam question, right? So actually, there's still room for improvement, but we should recognize that it's already, does way more than what I originally expected. Because originally I thought, well, yeah, it probably wouldn't get it right, right? So anyway, but we also say, well, then can we improve that? Actually, we pick one specific problem in collaboration with Optimum AI. So it's we want to predict the diagnose of a patient for the next visit, not this visit, but the next visit, like a few months down the road, to see whether we could do the prediction. And we are only interested in predicting like some new disease. If it's already diagnosed, like I said, well, somebody have heart disease. 6 months later, somebody else still have heart disease, right? That's not what we want. It's like any new, right? So any new diagnosis in terms of the ICD code. And then we say, well, how well we can do? There's already machine learning models, very sophisticated machine learning models. If you look at the neural network architecture, there's many layers of different things. And to give you like a SOTA accuracy about 30–40%, depending on how difficult the case is. So we run the vanilla, like pre-trained large language model to say, well, feed everything to large language model, how it does. Actually, it's only give you less than 30%. Right, still gap to the SOTA model. And then we say, well, can we leverage that? And then using LLM, not just, as the whole thing, but use it as a component of our whole pipeline. And then can we do better? Actually, it's an ongoing project. We can reach about 60, sometimes 65%, right? Which is better than without LLM. So if you think about what LLM can provide in this scenario, it's give you actually a huge capacity there to comprehend and store knowledge. Because otherwise, it's, previously we always want to store our knowledge in a very precise way, in a very structured way, right? And some of the knowledge is easy to store in that way, but some are not so easy, right? If you think about, you have this medical record, right? You have an image, you have clinical narratives, you have all this tabular data with all the lab tests, and you probably have some time series data like all the EKGs, all the things, right? And then not everybody have that. And then and also all this collection of data not in a synchronized way, right? So it's whenever the patient gets some test or not, right? And you also have this treatment, right? So all of those, right? And if you look at all the patients, they're all different. You can't really try to align them in a very precise way. That's making it difficult for storing those data and knowledge in a very structured way, and still hoping that it's capture the most essential information that you need, right? Your model needs to be more flexible than that, and LLM is one of the ways. I'm not saying it's the only way. It's just one of the ways to show you that by having a large model that nowadays 99% of people treat it as a black box, right? But not knowing how it's stored, but somehow it can be trained to store that, right? Most of the users don't need to understand how it stores the knowledge, but it can capture that. And our job on the other side is to actually develop models that can help LLM to better store or better capture those information, right? And also once the data tool evolves, right, as the new data comes in, how do we update that, right? So I think that's actually give us one really a good hammer, right, to solve many problems, to put down many of the nails that are harder to do in the past. That's one example, right? Another example of AI, which is a little bit different from LLM, is actually, we know like in many scientific disciplines, right? So simulation, right, takes a huge amount of computing resources. If you look at all the supercomputers, in the past, about 80% or even more are consumed by simulation, large-scale simulation. And it's very essential to, many disciplines, right? If you look at the chemistry, if you look at biology, if you look at like material science, physics, atmosphere, like climate, so a lot of simulations. And then that's one of the problems why it's become so expensive computationally is because it has this huge system setup, right? And either it's a huge optimization problem, or you have to solve some kind of differential equation, like partial differential equation, or stochastic differential equation, all different kind of differential equation you have to solve. And then that's consume all the solvers as really computationally intense, right? So lately, there's not just our group, but many other teams, right, engaged in the past several years to see, well, how do we actually accelerate that computation by AI, right? The idea is not to explicitly solve every, partial differential equation explicitly using those solvers, but really say, well, can we build, like using neural network, for example, right? It's one of the ways to predict what's going to be the value you have, right? Maybe after 500 steps or 1,000 steps, right? So especially if you're interested in a little bit of long-term outcome. So then that can help you to get there much faster. Have already been quite a few of the works, including our own, in that space, right? Demonstrated that not only actually the accuracy improves a little bit, right? At least you don't compromise the accuracy, but it's much, much faster. So that's one of the areas actually AI can really come in to help. And then so that it can greatly, scale up all those the simulation, right? Is either make it much shorter, the same simulation, but also like at the same time you can see, well, it used to be you can simulate maybe 100 particles, right? But now you can simulate 1,000, 10,000, 1,000,000 particles, right, at the same time on the same machine that you used to use, right? So you can see this. Of course, all of those are work in progress, but for those work that give people the hope that if you do the AI and data science right? So actually, what's traditionally hard problem may come, as there's a new solution. At least there's a hope, and then we shouldn't, stop there, right? So, and that's why I say that, now we're in the era that actually the AI and the data science can really, revolutionize many of the sectors that we were talking about, right? So we're, in our life, it doesn't matter like, what job you're doing, right? So, and what you're interested in actually is being impacted in a positive way. Thank you.
Thank you, Wei. I actually have a quick question for you. So you said, just going back to your first example, when you said that your ChatGPT kind of got 40% of your exams questions. Do you think your students are using it for, and also do you think that they know how to use it to do much better, to actually get A's on their exams?
So because of our study, right, let me tell you why we start to look at that at first place, right? So when ChatGPT just came out, my students are just so excited. And then it happened to be the time we need to design the final exam. So my TA said that, well, we needed to change all the exam questions. I said, well, can we just change 50%? Or they said, no, because some of the questions actually ChatGPT can answer it right. So, so then we realized that, right? So we need to see, what's the, in large language models capability of answering those questions, and actually, from that point on, all of our questions, doesn't matter it's homework or exam, right? So my TA always, try any of these available large language models to make sure that large language model give you the wrong answer. And then we put in the, in the exam so that whoever you said, sorry. We even say it to the student, forget about use. Yeah. So that, then, yeah. So, I mean, they're smarter, right? So if it's multiple choice question, then they make sure they don't select that. But that's actually, that's inspired us to do a more systematic evaluation about ChatGPT's ability. Actually, what I didn't say is like, if we actually prompt ChatGPT not to just solve the problem by itself, but really call for other help, like help you to write Python code, right, to solve your problem, or help you to call maybe the Warframe to solve some mathematical problem, or you do something like allow you to call another program, right, and then the ability to solve problem solving is much better if you allow ChatGPT to do that. And I think which is the future trend, right? So ChatGPT is, think about it, it's just your general contractor, right? And knowing when to do what. As long as, it can serve that role very well, right? So we may have unlimited, capabilities that we could explore.
Okay, great. So I actually have a quick question for Lola about one of the things she raised. So, I was thinking about your example when you talked about the fact that you sometimes don't have the image for the patient, and because of that, the prediction can be so far off, right? Can you comment on, do you work on trying to identify when that would be, or because that obviously is a source of bias that people don't think about.
So the problem we're dealing with the original setting, I should have given the context, where nationally, the screening rate for diabetic retinopathy was about 65%. It was about 25% in those settings, which means that for most of the patients, so without introducing, so we first introduced teleretinal screening, telehealth, which allows you to capture the image. But that means that for many people, for almost 65% of that population, you don't have an image. So using machine learning, we basically created a deep learning model using data from thousands of patients, EHR info on hemoglobin A1C, all the proxies, all the things that would kind of give you a clue as to what's going on with diabetes, causal and associational. So if somebody has diabetic kidney disease, yeah, they're probably likely to be progressing in terms of their vision loss. So while it's not as good as having, creating a convolutional neural network on the retinal images, we can get to 70–80% sensitivity and 0.8 area under the ROC curve. It's not that bad. Yeah.
Okay, great. So I wanna add actually one kind of example from my research, which I really think is orthogonal. So what we've heard about is people either using AI as a tool to solve a research problem that they're interested in, or fundamentally studying AI systems as an object and understanding how well they do on exams and their properties. But I want to actually talk about a third angle, which I think is very, which is, I think, a huge effect and affects me very much, is thinking about AI as just a productivity tool and a tremendous productivity tool. And I'll give you an example. So I am a computer scientist, and I got my PhD in, a long time ago, 20 years ago. And during that time, I think during my PhD, I would say that the majority of my time was spent coding, right? I was coding, and then only at the very end, I would do a little bit of writing, and I hated that part, but I was mostly coding. And then, as my career progressed, the amount of time that I spent writing emails, grants, et cetera, slowly increased, and the coding actually went kind of to zero relatively quickly, right? To the point where the languages that I knew are now extinct, right? So, and so then you really have no hope to do this, and then you've got this situation where you really you really need your graduate students, because it's, no matter how, at the end of the day they hold all the cards because they're the ones that can code, right? But then I had a interesting experience during the pandemic, because I was part of the SwabSeek project, and that project was really characterized by the faculty going into the labs and doing everything ourselves. And so my colleagues, were in the lab doing the experiments to actually get the technology going, and me being the computation person, I wrote the code. This was the first time I wrote code, maybe 10 years, and I was like, oh, this is great. Much more fun than writing grants and emails. But that was a special time because there's literally nothing else to do. I mean, the whole world was shut down, and it was a unique environment. But then when life came back, there's no time. And however, the tools of like ChatGPT for getting these kinds of work done is so revolutionary that I'm able to do all of my coding again, because, all these, a lot of it takes a lot of time, like things that take time, like for example, installing software, making sure it works on the Unix environment, they have the errors, right? Any challenge like that, actually ask ChatGPT, what commands do I do to install the software? And then if it doesn't work, I say, I got this error. It says, oh, do this. And then if I got this error, do this. And sometimes it says, oh, you need to upgrade your zlib to this, and the command has like sudo and all this kind of stuff, which is probably potentially irreparable damage to my computer, but I don't care, I tried, and so far so good, right? So these kinds of things, or, I have a bug, I no longer try to find it. I just give it the piece of code. It tells me where it is, this kind of thing. And remarkably, I guess the benchmark here is, can you, a faculty with ChatGPT, be faster than your graduate students at the same task, right? And, the answer is sometimes, right? But I think that it's able to automate so many of these routine things that you can really, it's not there yet, but it's much closer to, you have an idea of what you want to do it really, you just tell it what to do. As you use it, you get more experience. It can, all these routine tasks like debugging. I mean, it's not doing anything sophisticated. It's kind of, if you Google the error you have, you go to websites, you could find the error, right? It's kind of just a very automated version of that. But in terms of like my productivity, it's remarkable advance. And I'm actually able to do that. And I think that's something that, we have to really think about our staff, our teams, our researchers, how they, like to really use these tools. Okay, so
I have a quick question for you.
Yeah.
So, because when you said sudo, okay.
Yeah.
How do you trust that it's not hallucinating if you're going to put in a sudo command that could really?
Well, I do the I mean, I do the cost benefit calculation, right? Which is that this is my laptop, right? It's my laptop, right? The worst that it's going to do is I'm going to have to just a lot of time. But on the other hand, it could save me other time that I would spend doing, there's like some probability that it could go really bad, in which case I would lose a lot of time. But, otherwise, it's, so maybe that was a bad idea, but yeah. But clearly I do not do that on any system that is involving patient records. Just want to be clear, right? Okay.
Actually, I was going to say, because it builds on so much of what you guys have been talking about, there is this growing literature on, we have these AI systems that are being kind of increasingly used in real world settings, like radiologists now, kind of uniformly use kind of, AI systems. The state of New Jersey just transitioned to a very large kind of AI system for helping predict the probability that somebody we just arrested, if we let them out on bail, will not show up at their court date. And they've started kind of pushing that out. And so there's this increasing social science literature on, how good are people at where humans actually, in the final instance, have to make the decision. How good are they at using these AI systems to increase their performance? Like, do we want hybrid systems? Do we not non-hybrid systems? So many of you probably know, at this point, the best AIs can perform at about the 78th percentile of radiologists. Like, you look at a lung scan, like there's persistent differences between radiologists and like how good they can do at identifying, say, like, lung cancer, and AIs can do pretty well. You would think then that you can just expose kind of radiologists to the output of the AI. And heck, at least like almost 80% of radiologists could improve their performance just by ignoring their own kind of intuitions and just doing what the AI says, right? And maybe, but it turns out it almost uniformly dampens radiologists' kind of performance if you expose in some, like Nikhil Agarwal has this work that shows that radiologists are very bad at identifying the time, like in some sense, correlation neglect, like times when the times when the AI is picking up on signal that they actually have already taken into account versus when it hasn't. And like, I think there's a growing literature on exactly how people can augment their own, and the ways that people actually and the ways that people optimally can augment their own kind of decision making using these things. That's fascinating.
Okay, we're gonna switch to questions, but I wanna just give everybody 1 minute to answer the following, which is it's my first question, so it counts. Okay, which is UCLA is very interested in this area. We have a lot of strength, spread throughout the campus as evidence in this, but we don't have like a Johns Hopkins, $100 billion institute, or a school like Berkeley and UCSD have, right? So, what do you think? What do you think UCLA should do, right, to move forward in this area? And just also add to that, kind of what could UCLA do that would really benefit your specific research? Any order, yeah. Wei, you want to go first?
Okay, I can go first. Well, I have a lot to say, but I will make sure it's 1 minute. Okay, I think I do recognize all the there's. Many other schools that we saw it in the news, right? So they have huge investment. I do believe that actually UCLA really should do that, right? So, and I'm not talking about the dollar amount, but this type of investment and activities, and so there's a number of things specific. I think we can do well, or if we start right now, it's like, hey, we want to be maybe like engage industry partners, right? So they can sponsor a lot of the activities that we want to have on campus. And then, so we really need to, at the campus level, not the individual faculty level where we all like work with some industry people, but at the campus level, right? There should be an initiative to really massively engage them. And the second is how think through like, in terms of, for example, faculty recruitment, right? How we really in the next, not next 10 years, but next 3 years, right? Invest in this area, right? So, because I can speak from like computer science perspective, I'm sure it's true for maybe in the math or stat or ECE and all this relevant department who's working on the foundational side, we are very overwhelmed, right? Because the demand from the student is so high, right? We really overwhelmed, right? So we need investment in that, in really maintain the level, of education quality. So, and also, we also need a new mechanism to really engage faculty in new research, not just doing their own research, but collaborative, interdisciplinary, actually research in this space, AI and the data science.
Okay, that was a great 1 minute. Okay, go.
Okay, I'll go even like 10 seconds. I'll go to I agree with everything there. I'll just say, for example, like David Luong is here. He's kind of the head of the research computing cluster at Anderson. And one thing that stuck out to us, we just, bought a H100, just a very good graphics card, right? Like, and my God, if you had asked, what are the returns to the cost of this? I mean, it's just been incredible. Even, the kind of economic returns to even just basic computing resources. I mean, of course, it all becomes immediately overwhelmed, but it's been tremendous for like all of the graduate students and the faculty at Anderson, even just to have that dedicated resource. The returns are huge right now. Yeah.
Okay. So I'm not primarily based at UCLA, and I am a computer scientist. I have bought a deep learning server, so I'm a bit of a hypocrite. But I'll say that I think we need a lot more of the should we do it people than the can we do it. Because I think there are a lot of unintended consequences that we don't explore as much. We kind of on the back end. You know, you were talking about AI in bail decisions, and I just remember I've read like 5 articles so far on, you know, facial recognition AI that's being used by police, and like wrong people are being arrested, and that just makes me very nervous. But yeah.
Absolutely, it's good. It's an important topic.
Okay, great. Let's open up to questions from the audience, and maybe we can start it with in person. Yeah.
I have a question for Wei. Yeah, so I guess I'm interested in the medical record, like health data paradigm that you were talking about of like we used to have, I guess, specific tools to do this prediction, whereas now we have a bunch of multimodal data, we don't know what to do. Let's say a naive solution is I feed it into ChatGPT, I say, summarize this patient, 200 words, and now I can stick it into my like specialized tool to predict this patient's like next health problem. Do you see this as like a fundamental shift of like we can now use these large language models to like embed complex data and then go back to our specialized tools to solve this? And like we've switched from this paradigm shift of we need specialized data to fit into specialized models to now we can have just whatever data we want, and we can now like force it to fit into some constraint by using large language models and then go back to this like specialized models? Or do you think that large language models are kind of just on their own, we can fine tune them or like improve them in some way so that we can just use them?
Well, that's a great question. I do believe that those specialized tools, right, there's still space for them, right? They're very useful, and I think I mentioned somewhere like large language model can serve as a general contractor, right? So, and if there's a task, there's already a specialized tool that can do well, right? Then large language model should be able to recognize that, and then whenever needed, right, just call that tool, rather than try to do everything by itself. I think that's going to be the trend. It's not like one model try to do everything, but this model is smart enough to know when to actually invite external help and when to solve it by itself. So I think that's going to be the future trend. But in terms of the medical data, right? So I think we've mentioned a little bit. It's like there's also tremendous opportunities for people to really investigate like the trustworthiness of the AI system, right? So there's another line of research. It's called trustworthy AI, or sometimes people call it responsible AI. So that's really try to address all those issues that we mentioned here, the concerns we mentioned here. But my personal feeling is that those are important concerns, important issues we should not ignore. But because of that, we at the same time we should not stop doing AI. We just want to make the AI safer and fair, right? So for the future, right? Yeah.
Yeah, so I guess, do you think it's like now we can have arbitrary data that we can like fit into this constraint so we can now use it in specialized tools? Or do you think it's just like we can feed data into ChatGPT and then see kind of what it says in general?
Well, you can use ChatGPT or maybe fine-tune the ChatGPT, right, to help you to summarize your data. I think that is already doable these days, to help you to summarize the data or organize data in a better way, or even try to fill in some of the blanks, right, in a better way. So so that actually when that data becomes the input of your specialized tool, right, and the performance is even better than just you feed in the raw data. I think that's also doable. Yeah.
Cool. Thank you.
Thank you for the wonderful panel discussion. I'm a statistician and a climate scientist, and increasingly trying to use AI for kind of those science purposes. And my question is The analog was brought, or the analogy was brought up before about kind of AI to a calculator, that, you know, the calculator or the AI can give you these really good hints, and then you kind of turn on your science brain and try to understand what's going on after that. Keith brought up, I think, some relevant examples about kind of causality and adding and taking away trees and stuff. And I just wonder about your thoughts on if and how these ideas come up in your research. And I think this idea of kind of explainable AI has all this promise, but I haven't seen a lot of huge successes out of that. So it doesn't seem like we've kind of solved this issue of how do we then interrogate our AI. So how do you, if at all, think about kind of, if you will, the science part of it or the kind of investigator part of that after you do your initial AI explorations?
I can take a quick shot at that. I mean, I think it's one of the most important questions that face us as kind of scientists who are starting to utilize kind of AI. I'll give you an example, not from my research, because I want to give you good examples. There's, you know, I'll give you an example where, of I think a really interesting thing. There's a study, a recent study by kind of Ludwig and Mullernathan who kind of do this thing, you know, kind of scary situation, but like long story short, take parole boards, right? Like, you know, they're making decisions as to whether to release people from prison early. So it's obviously a life-changing, extremely important example. You know, take the dossier of people, you know, all of their performance in prison, all of this stuff like that, and summarize that data. You know, you can do pretty good at predicting whether somebody's going to be released using that. Take a headshot, you can do even better. Okay, just with an AI, facial recognition software, like, you know, deep learning model. But you have no idea, like, what to do with that, right? Like, okay, you know, so you can tell a lot from a person's face whether a parole board's going to release them. That's kind of scary, right? But, like, what do you do with that? So, you know, what people are starting to do is kind of, like, stack these AIs to try and make them understandable and to also kind of get at causality. They'll do things like train up a generative model on the output of that first stage kind of deep learning model. To predict the kind of decisions of the first model, and now take that generative model and feed it just all of our faces, okay? And say, listen, along the direction of greatest descent, I'd like you to make Terrence's face 10% less parolable, okay? And ask, like, what does it do to Terrence, okay? And it turns out, you know, it you know, narrows his eyes a little, it darkens his skin a little. It does several things that, like, you know, we might all find kind of a little bit terrifying, right? And then so that in some sense is like using the generative model to generate scientific hypotheses that we can then, you know, we don't kind of quite have causality yet, but we can, like, now we can think hard about, you know, it's kind of generating hypotheses for us, which is an important scientific activity. And then, you know, and then you can kind of double check this by saying, like, now I have, like, a bunch of before and after pictures, right? I've got, like, Terrence before the AI gets to him and Terrence after, and then I can ask humans what is most salient between these two pictures, right? And the human can say, like, well, it's clearly made his skin a little bit darker, and that helps us kind of, like, you know, kind of in some sense interpret and interrogate the deep model. So there's some stuff like that, and your question is so deep. There's way too much stuff to talk about, but there's a lot, but hopefully a flavor of, like, what people are doing in this direction. Anyone else have?
Okay, maybe we could take the next question also. Yeah. Any more? Yeah. Yeah.
So I see a lot of danger in this. Whatever your discussions have been. Looks like a lot of compliance is needed for this kind of technology. Any progress on that?
Yeah, I guess the question is that the question is, it's dangerous technology, and there's questions we need compliance or kind of structures like that. Is there any progress on that? Actually, we have another panel later this afternoon that I think are kind of experts on that, but is there any of you want to comment on that?
So there are a lot of people doing work on, you know, algorithmic justice, on bias. There's a whole lot of work being done out there, but I think generative AI in particular has captured the imagination in such a way that I don't know, you know, it's exciting. And so those pushing back are probably not going to get the same amount of attention. But, you know, the AI Bill of Rights coming out of the White House and some of the other initiatives may help us to sort of take stock about of what the potential consequences of all of this is, and to try to do things a little bit better, so that when you're trying to create models that essentially, in some cases, perpetuate biases in society, like the parole board and policing examples, where, you know, you feed an AI, you train it on biased data, it's going to give you biased results that reflect the population, that we can kind of stop and think about it a little bit more. There are lots of people doing work on fairness auditing. Some are doing very sort of census, like mapping, okay, if you have a training set, you have to map everything to census data. It's not always appropriate, but, you know, there are people doing different kinds of work to try to address some of these issues. But I think we need ethicists. We need a lot more people engaged in this area. I don't know if anybody else has.
I can just add one real quick thing. Like, for example, UCLA Health System has a Health AI Council that is involved in basically kind of regulating and compliance to any AI or machine learning decision support system that's installed in the health system, and, you know, they have to show that there isn't issues of bias and there's, you know, working correctly and things like that. So I think that, you know, where it's needed, my impression, like, that's a very clear kind of, you know, deployment of a system. You know, where it's needed, there is some, you know, they came up with the structure on how to do it, right? But I think the question is, there any kind of guardrails on the research, right? Or, you know, just, you know, that I think is still being developed. Okay, yeah, actually. We can, yeah.
Yeah, so this is a great discussion, and I'm wondering if there is a way to generate such cross-fertilization that's going on right now, right? So to give an example, I heard about all of your work today for the first time, and you mentioned how consumers are being driven to make certain choices based on putting something on the screen. Now, one can put that research to good use to say, when I teach in a classroom, where should I put the relevant equation, right? So that, you know, it's the same consumer. There must be similar biases. So can we put those things, the principles we are learning here, what can we do at UCLA so there's cross-fertilization? And I don't know, there's some common website where somebody writes a 2-line summary to say, hey, we found this, and then somebody like me will come up and say, we'll modify my slides accordingly or something, right? Or even research projects. I think that will be pretty useful to do something like that.
So I thank you for the question. I mean, I'll answer this one, actually. So thank you for the question. I mean, that's really the idea, right? So, you know, this event is jointly sponsored by DataX and IDRE, right? And you know, the goal is that DataX will become such a community, right, for this kind of cross-fertilization. So there's, you know, is Sophia here? Oh, she's here. So yeah, maybe, you know, maybe Sophia, can you, like in Mark, so Sophia, do you want to introduce yourself real quick for people that don't know you? So yeah.
Hi, no pressure.
Yeah, sorry, yeah. Yeah.
Great to meet you. I'm Sophia Noble. I'm the David O. Sears Presidential Endowed Chair of Social Science, and I'm here at UCLA. I'm one of the DataX faculty directors, along with Mark Hancock here, my colleague who's the chair of statistics, and Chris Johansson, who's from the Digital Humanities program. And Eleazar is right, our colleague, we are trying to build an interdisciplinary community. It's really interesting to listen to this panel because I've been working on racist algorithmic bias for over a decade. And many people in this room and who will be joining this afternoon also work on these kind of social science, humanistic inquiries into technology and AI. So I think there's a lot of desire to answer the question, to collaborate and build different paradigms of thinking. I can say that, 15 years ago when I would be in a room like this with computer scientists and mathematicians and statisticians, and I would say that algorithms were discriminatory, that was heretical. And in fact, I would be shouted at. So, the fact that we have normalized these conversations because there has been so much fertilization, cross-fertilization, connection between people in social sciences and humanities with people in computer science and other kinds of fields is very, very important. And we are at the cutting edge, I believe, at UCLA. We have some of the brightest stars in our fields in the world at this institution, and we don't have the College of Computing or College of Data and Society yet. But I think that there's a lot of opportunity here. So please go to the DataX website, sign up and become affiliated. If you're not yet, let us have more workshops, more small gatherings, more opportunities like this. And we're really concerned and have a deep expertise that we can add to these kinds of conversations in terms of the social, political, economic dimensions of this work. So thank you so much for all that you're doing.
Great, yeah. Maybe Mark, you wanted to say something? Yeah.
So I won't add too much to what Sophia and Elazar have said. To my mind, one thing that's important about UCLA is we have great strengths in data science fields and data-centric and inquiry. So the main role of DataX is to do things that are not naturally done in the university because of the many barriers that naturally exist between different groups and different views. So a primary role of DataX would be to enhance data-centric inquiry across fields in a collaborative way. So I look forward to working with everyone here and other folks in the coming months.
Chris isn't here, I think. He must have stepped out. But he's also here. I think that I just want to, just we're closing, we're over time, but I want to just mention one thing. So, the way that DataX is currently structured is that there's these three pillars, the foundations, kind of data justice, and innovative applications. And they are, they're all part of DataX, but they're somewhat work independently. They have independent authority to do hiring, joint hiring, et cetera. I think it's a great, UCLA is such a big place. It's so diverse and so many units. I think it's actually a great structure, and I think it'll be very effective. But I think one of the reasons I'm very we didn't pay you to ask this question, by the way. That was completely spontaneous, right? But I think one of the really key challenges for the community is that, all of us are, have a lot going on, and we have many different things, and so adding yet another, kind of administrative unit that we're a part of is a challenge. But we are hoping that we can have DataX contribute to these kind of infrastructure needs like computing resources, et cetera, that would, make it make sense for a lot of us in this room, to be very actively engaged. So, in addition to kind of the, scientific interest and things like that. Okay, so, okay, thank you. So, thank you.
Thank you so much to our panelists, Eleazar, for leading the discussion. For all of you, lunch is being served just out these doors. Please grab some food. There's also a poster session during lunch, so please stop by and support the graduate students. If you prefer to eat outdoors, there's a 6th-floor balcony, which is a great place to socialize as well. So we'll see you all back in an hour. I hope everyone had a great lunch. Our next session is going to be a great slew of lightning talks. And Jeff Burke, our Associate Dean and Professor in the School of Theater, Film, and Television, as well as the Director of REMAP, will be the one to chair the session. So thank you, Jeff, and feel free to take it away.
Hi, everyone. So we have 3 lightning talks today. I'm going to give some brief introductions. We'll have a 10-minute talk followed by a couple minutes of Q&A from the audience, and if we can sort of stay on schedule, we'll bring everyone up at the end for a little bit of synthesizing discussion. So the 3 speakers today, and I'll give you the order of presentation, are Janie Roundtree, who is the founding executive director of the California Policy Lab at UCLA. She's a member of the National Alliance to End Homelessness Research Council, and is the co-author of several reports on homelessness in Los Angeles. Silke Moon is an associate professor in the Department of Earth, Planetary, and Space Sciences at UCLA. Her research focuses on understanding the interactions between tectonics, climate, and surface processes that shape the Earth's landscape and induce natural hazards, including landslides. Aditya Grover is an assistant professor of computer science at UCLA. His research interests are at the intersection of generative AI and sequential decision-making, and grounded in applications for improving science and sustainability. And so all three have the brief of looking at innovative applications of AI in the context of research, and so we're happy to have them all here. We'll ask Janie to come up and get started. There will be a sound like this when we get to about 10 minutes, just to see if we can keep the lightning talks on schedule.
Thank you. Great, and I can just use this? Okay. Hi, I'm Janie Roundtree. I'm the executive director of the California Policy Lab at UCLA, and I run the lab with economics professor Till van Wachter. I just wanted to mention up front that my background actually is, I'm a lawyer, former criminal defense lawyer. I've worked in public policy and government for most of my career, and I'm here on behalf of a much larger team of researchers working on this project. So I encourage you to ask any question you have, but if you're gonna ask a super technical question, I might refer you to my colleagues, but it's a pleasure to be here today. So our mission at the California Policy Lab is to generate research insights for government impact, and we do this through a variety of mechanisms, but one of the most important ones is that we work collaboratively with public agencies in California in every aspect of our research, from forming research questions to interpreting data, and we do that to make sure that the end result is going to have an impact on a budget or a program or some aspect of California policy. And the partners for the project that I'll be talking about today, predicting and preventing homelessness in Los Angeles, are the LA County Department of Health Services, which is our local hospital system, the LA County Department of Mental Health, our public mental health system, and the LA County CEO, CIO, or Chief Information Officer. So I'm going to start by talking about Dulce Valentin, and I should say that she has consented to me and others speaking about her story. Dulce met her partner in prison several years ago. They were involved in gangs, they were released, and Dulce suffered from a number of different mental health issues that kept her out of the labor market and also housing unstable. She was living in a dormitory-style environment, having sort of exhausted the patience of her friends and family. They were living there together, and she got a phone call from LA County DHS, from the group called Housing for Health, Homelessness Prevention Unit. And the phone call sounded something like, hey, we haven't seen you in a couple of months, but we have some questions. How are you doing? How's your housing situation? Would you like to enroll in a program that you qualify for, where you're going to get some financial assistance immediately and potentially help finding a better housing situation? And I start with this story because Dulce got that phone call from the county as a result of artificial intelligence research happening at the California Policy Lab at UCLA. So I'm going to talk a little bit about how we got from our research to that phone call. I should say before I move on that she did enroll in the program. She did get financial assistance. They were able to find stable housing for her, and she re-entered the labor market at working in the transit system. A lot of times people need housing in order to make progress on their mental health and labor market goals. So our motivating problem for this project is the crisis of homelessness in our community. You may be aware that 75,000 individuals are experiencing homelessness on any given night in Los Angeles, but it's more like hundreds of thousands unique people over the course of a year who are coming in and out of our crisis shelter system or living on the street. The county is housing record numbers. We have never housed as many people experiencing homelessness today than we have in our past, but the population continues to grow because we can't keep pace, right? So the inflow is higher than our ability to house people. So The policy question that the county posed to us is, can we prevent homelessness? Can we reach someone at a critical moment in time and steer them away from the experience of living on the street or in crisis shelters? So what do we know about homelessness prevention? This is way beyond a 10-minute talk, but the headline here is that it works, or it probably works. There are a number of studies, including RCTs, that show that one-time cash assistance, if you give it to the person at the right time, can reduce homelessness. We also know it's extremely hard to target. So to put this into context, there are millions of people on public assistance programs in LA who you might think would be at risk of homelessness. Only about 1% to 2% of them each year will experience homelessness for the first time. So it's a huge crisis, but it's statistically very rare. So we thought that this might be an area where we could explore the utility of predictive analytics or machine learning or AI approaches. Can we use big data to understand who's at high risk of homelessness in Los Angeles? And of course, for our lab, it's not just a paper. We needed to know, if we did build a predictive model, who in the county would use it? What's the real application in the real world? And if you work on models that are used in real life, you know that how it's used is hugely influential in how you design your prediction problems, select your sample, design your features, and all of that. So anytime you think you have a prediction problem, you have to start with what are your data sources? How well do you observe the population at risk of homelessness, and how well do you observe the outcome that you're trying to predict, which in this case is homelessness? We're very fortunate to work in a research partnership with the LA County Chief Information Officer, who for many, many years has been building a linked, longitudinal, integrated, individual level de-identified data set in Los Angeles, right? So this is pulling data from our hospital system, our public mental health system, from jail records, from probation, from child welfare system, all of our public benefits programs. If you're familiar with CalFresh, that's our food stamp program. CalWorks, that's the TANF program, general relief. And it's linked at the individual level. I want to emphasize that we see a mirror copy of this. We see no one's identities. It's privacy protected, and our lab is HIPAA compliant. So we're going to use all this information to generate features to try to understand who's at risk of homelessness. One of the hardest things about this project, or anyone trying to predict homelessness in California, is observation of the outcome. And the way that we do this is to look at enrollments and homeless services. That's pretty accurate, but many people experiencing homelessness in LA are not enrolled in services, so they're not generating administrative data. So we also look at all of these county departments when they flag anyone, maybe in a hospital or in a safety net program. They say in the data, we think this person's homeless. We're going to capture all of that as well. It's important to keep in mind that these definitions are different, right? But we're rolling them all up into a single observation. So our use case here, we asked the county, how would you use a predictive model? And the answer is that they wanted to create a whole new unit within the health system called the Homelessness Prevention Unit that would take risk lists. We would generate risk lists at UCLA, send them back, they would re-identify them, and actually call people on this list. So they wanted a rank-ordered list of people that are at highest risk of homelessness that they would actually call, right? So that's very consequential. You can imagine all kinds of use cases for this, maybe flags and automated systems. Government technology is very old. This is the way that this use case made sense to our county partners. So that triggered a number of different decisions. So we needed to make sure that we were sending clients of DHS for privacy reasons. They needed to be able to re-identify the data, so they're in a client-patient relationship. They needed to have recent service contacts. We couldn't just identify people who'd been seen 10 years ago because the likelihood of finding that person is very low. So that further shrunk the sample. They needed to be adults. And most significantly, we needed some signal in the data that they were still stably housed. There are 3-month data lags in these systems, and homelessness happens very quickly, right? So we wanted to avoid the risk that we were going to send risk lists. Everyone on the list is already homeless. They qualify for homeless services, but they don't qualify for prevention at that point. So our prediction problem, we ended up with a sample of 123,000 people who met these criteria, and our job is to predict homelessness among this group. So how well did the models perform? We ran a number of different types of models. We tried logistic regression, but also boosted trees and all other kinds of things. We have a big technical description of this if you're interested, including model validation, but it was running on 580 features, and it's these individual interactions with these services, with the jail, with emergency departments, public mental health services. And the risk list that we generated had 10,000 individuals on it. That's a really big list, and I'll talk for a minute why, but that list had a precision of 24% compared to 7% prevalence. So it's a big improvement, certainly over random guessing, and good enough precision for the county to use this in targeting the program. So how does this actually work? We generate these risk lists at UCLA. They're de-identified. They're sent back to the county. The county can re-identify them in their own computing environment. And then the county cleans the list. They look for people who are already homeless or may not qualify for the program. And then at that point, they're sent to the team for outreach. There's also a randomization at that point because they can't serve everyone on the list. They're randomized for purposes of an RCT. And then the list is handed over to people who work in this unit, and they literally call people. And the enrollment rate is about 20%. It's very low. It's beyond the scope of this talk to talk about this, but this is what it's like to do this work in the real world. Like, some people's contact information is not up to date, can't reach them at all. Some people are not interested. Some people are skeptical. But when they do enroll in the program, we've had over 1,000 individuals enroll in the program since the start of the pilot. They're getting on average about 6,424 in rental assistance, a variety of types of other services, installing a breathalyzer in a car so someone can go back to work, buying an e-bike. The program is very flexible. They're also getting reconnected to primary health care and primary behavioral health care. The RCT results are not in, but just as an early signal, about 90% of the people in the program are retaining housing by the time they exit. We're running an impact evaluation, and then we work literally on a daily, if not weekly basis to help them improve the program. So I do have another client story to share, but my time is up. So if people are interested in hearing about Ricky Brown, maybe we can do that in the Q&A. But thank you so much for having me today.
Thank you. So we have time for a question or two. Go ahead.
Yeah. Hopefully this isn't controversial. I've worked a bunch with homelessness in Santa Monica. Is it in the future also maybe possible to identify who you can most successfully lift out of homelessness with the data?
That's a great question. It's certainly not something that we've modeled, partly because there's so little research evidence around what works for whom. And so I think you might need that as a baseline set of guiding principles. There is quite a lot of evidence that you can lift really anyone out of homelessness. It just depends on whether you have the right intensity of services, right? So there are large health studies, for example, that people currently experiencing substance use disorder and behavioral health can succeed in housing, but that housing needs to have usually assertive community treatment or similar services attached to it. So there's some evidence around that, but we haven't been able to model sort of the stratification. I think an economics question is, what can you do for these people that lifts them out, that's minimally invasive in their lives and in the system?
Hi, really great talk. I was curious why the 25 plus head of household was a risk factor to start with.
It's not. It's actually a feature of how homeless services are organized in LA. There are 3 population types. There are unaccompanied adults, age 25 and older. There are families with a head of household. And then there are what are called transition age youth, who are age 16 to 24. And so if you have a head of household who's age 24, they're in a different bureaucracy with different funding sources. So it has nothing to do with the modeling or the data. It has to do with how you deploy resources for families and people.
Great. All right. Thank you very much. We'll have hopefully a chance at the end to have one more question.
Hi, everyone. Hi, everyone. Thank you for inviting me to talk about AI and machine learning applications for the land surface hazard. And here's the photo that I took from after the Montecito debris flow event in 2018. And as you can all experience, that actually learning about land surface hazard, including the landslide and debris flow, are very important for our life. So this work, I'm a physical scientist. I'm studying the mechanics and chemical interactions and processes of Earth's surface materials. I'm geomorphologist specifically, and I'm the Department of Earth, Planetary, and Space Science. And my work that I'm presenting today is a collaboration with Louis Bouchard and Khalid Youssef in chemistry department, that he's an expert on the biophysics and physics that developing the machine learning models. So it actually started with a coincidence that Louis come to me and then ask, oh, I'm an expert in machine learning, and do you have any problems that you're interested in? I said, oh, I'm interested in landslide. Okay, let's study together. So it's kind of coming from the coincidence that chatting with a colleague and then come up with some interesting idea together. So if you are like, wow, we experienced all this mudslide last week, that you found that there's 500 mudslide and flooded and broken bridges in California facing a very long and costly storm recovery. And if you feel like, it's not just once, it seems like it's more happening more frequently, if you feel that way, it is actually true. So this study is 2020, actually compiled all the existing hazard event, including geomorphic hazard, including landslide, debris flow, and flood, and climatic event like tornadoes, hurricanes, and drought, and heat waves, and also compare with the geologic events like volcanoes and earthquake. And you can see the lines are increasing from the past to the recent. It's mostly because of sensing technology. However, you see clear differences that emerges from the climate and geomorphology in recent years. And we think this is related to the climate change and producing an more extreme event, and land surface start to respond more quickly than this. So if this prediction is correct, people are thinking that in 50 years, we'll have order of magnitude more event in the land surface responding to this climate change. So, however, you can see that a lot of people, as our scientists, that some people, they have news articles about landslide kill and hurt thousands of people, but science largely ignored this disaster. And it's basically earthquake. Boom, it happened. 10,000 people die. And big flood and also big hurricanes. A lot of people got affected. But when you look at the number of people and also the building damages and it's affecting, it is actually affecting a lot of people. But many of the science doesn't know why it's happening or why some location is happening, some location does not happen. The science behind this hazardous event was not well known. But this became more important considering this climate change in coming years. So why now? Why do we need to study this one using the machine learning and data science? Is because now it became extensively available data, remote sensing, also ground-based sensing technology. So this is an example from the website from NASA. NASA now has Earth data open access repository, including terabytes of the data from Earth surface, from the satellite images with optical images, radar images, and also different type of data became available, and there are so much data is flooded in recent years. So I'll show you a couple examples that how we use this machine learning technology to better understand landslide hazard, and this is collaboration work that I did with the Khalid and Louis and my students of Kevin Shao. So one way people have using is generating their landslide inventory, that event inventory coming from the automatic detection using convolutional neural network. So this is an image from the Landsat image with 30 meter, and you can see some different colors. White colors are basically a bedrock exposed due to the removal of vegetations, and some of those little dots are indicating a small landslide event. And if, as a human, my students draw a line that where the landslide happens, right? But sometimes humans are very subjective. Oh, it looks like a little white or a little whiter than the green, but how do we know? So what we did is we generated a bunch of human annotated landslide and then combined with the remote sensing data to provide a more objective measurement of the landslide detection. So this is one way people start to detect this landslide using the image processing technique to provide a large data set of inventory to better understand the landslide hazard. And here's another important thing is after you supervise those data sets, you can have a much larger data set to generate it. So you can see in the previously, I have tens and hundreds of landslides, but now we can generate much more data set with a better trained data. And the second project is basically trying to understand better on the physical processes. To be really honest, I was doubting about the neural network because it seems to be a black box to me. I'm a physical scientist. I want to know why. And neural network never tell me about why. They just produce a perfect result or better result, but I do not know why it's better. So what we come up with was I have a multiple conversation with Louis and his students and my students, that Louis and Khalid is shown in the figure because they could not come to here in person. But we want to know why, and what they come up with was that we tried to create an interpretable neural network, explainable AI model to better understand the processes underneath. So you can see the first diagram show the more traditional neural network, convolutional neural network, that input data produce model output, which is better, but the layers are hidden. So we do not know how they are interacted and what is the contributing more, and all this feels like a black box. And they come up with very simple neural network that is superposable. So you can see the known inputs, you're going into that neural network, and we will know exactly what is producing more and how much of the contributions of each variables and what was the functional form between the physical variables and the output. So that we called superposable neural network, SNN, and that's how we try to understand the landslide occurrences. So what they've come up with, what proposed was that this model, superposable neural network, was producing a compatible performances comparing to the deep neural network, but also it's slightly less, but provide better explanations. So here's showing the examples of the mapped landslide shown in the red, and the middle one is a susceptibility, which is where the landslide likely occur in the spatial domain. The higher area is where they will occur. Blue is where they may not occur. So they show a pretty good correspondence. And each of the locations, we will know what is the most dominant factors are contributing to the high susceptibility. And those colors are indicating different processes, which is the green one is indicating basically precipitation multiplied by the topographic slope producing the most dominant controls. Precipitation and topographic variables people have known, but sometimes they use individually. They didn't use the multiplications or interactions with it. And our work shows that precipitation multiplied by slope was producing the best result. And also they show some threshold behavior, which can explain by the physical models. So what we are trying to do in the next step was we trying to develop a time series explainable AI models that Aditya will talk about the more atmospheric components later. But we're trying to understand why and how does that vary with times, and how can we predict better on the landslide in terms of timing. So our goal is predicting the changes in susceptibility due to the climate change and atmospheric river, for example, and this is the goal to predict better and where those locations will be more susceptible than the other in the future direction. And we recently got funded from NASA, and we are looking for a graduate student and a postdoc. So if you're interested in these topics, then please send me an email, and it would be nice to talk with you.
So I have one question. If there's not, yeah, back there, great.
With the recent rains that just happened,
the question was, are you use the recent event, like last week mudslide or previous event, to do this modeling? I did within the Eastern Himalaya, which is a lot of people died on there, but we are planning to do on Southern California as well. And I know that some of the people working on the last year's atmospheric event, they also creating a lot of landslide, so there's been working going on. And I was looking for the data for 500 mudslide, but I couldn't find it.
got it. Thank you.
question in the app. I think this is for the speaker. If you can explain it or if you know what they're asking, let me know. How did flexibility in the unit's deployment of resources affect your team's work? Was this for this speaker or last? Probably last one, okay. It just came late, okay. So I have a question, if there's not another one from the audience. So I was curious if, as you start looking at new techniques, you're thinking about new types of data that you would like to get, like how the kind of current moment is affecting your thoughts on sensing or data collection?
I think this is a great question. So actually, there is some effort that people trying to do, especially in terms of the response, like the hazard response. So they trying to couple with the models and where will be the most damage is happening, give some information to the people on the ground, and then more targeted samplings and targeted investigations. So there's an ongoing research that people trying to do. Yeah.
All right. Thank you, everyone, for being here, and thanks for the invitation. So I'm a computer scientist, and I'm going to be talking about how modern artificial intelligence can have a very wide range impact on a lot of sustainability domains through the development of foundation models. So the particular focus of this talk will be on atmospheric sciences, and there's good reason to think about why atmospheric sciences is right now at a very pivotal moment. The year 2023 that went past was the hottest year on record. There was no part of the globe that was spared by some extreme weather event. This year hasn't started off on a great start either. We just talked about mudslides, and a lot of that was the outcome of very, very heavy rainfall that LA had not seen in its history. So this is really a global crisis. So this is really a global crisis, and we need to think about solutions to address it. Now, turns out AI is also at a pivotal moment, but the headlines here, of course, look more rosy. There is a lot of talk about how AI will be leaping forward humanity to solving a lot of grand challenges and reshaping the world that we live in. And the question is how, right? So, and there is some evidence. So we have seen the marvels of ChatGPT. We are seeing similar things happen for a lot of multimodal data, whether it comes to images, videos, and very soon we're going to have autonomous agents which will do a lot of our drudgery in terms of the tasks that we require. So a natural question here is, what about science? There is some evidence of how AI has solved some of humanity's greatest challenges in terms of predicting the structure of proteins. What I have been interested in my group is thinking about, can AI help address the state of atmospheric sciences using the similar ideas that have led to such large-scale AI systems as shown here. So my lab works at the intersection of foundation models and science, and today's talk will look at the intersection in the form of atmospheric foundation models. Now the keyword here is models. And model means many different things. So if you go to the world of machine learning, a model basically means some kind of system which is trained on lots and lots of labeled data, and then it solves a task, right? So it could be some kind of predictive task. So for example, you could use it for information extraction. You could use it to answer questions You could use it for chat and so on and forth. But what's been really interesting in modern AI is that this paradigm has actually been left behind in favor of what are known as foundation models, the biggest examples being ChatGPT. Here, you train a single system on lots and lots of data, for example, the entire internet, and then think about how this model can then be adapted to solve different tasks that you might care about. And we do that all the time with ChatGPT prompting, and we are increasingly doing that with also a lot of vision models in the picture. So this foundation models has been a big leap forward for AI. And now, if you think about what models means for the atmospheric scientists, it means something very different. It means physical models, so systems of differential equations, which are governing how matter and energy flow in the atmosphere. Now, this technology has also been improving, but the rate of improvement in last few decades has been not keeping pace with the urgency with which extreme weather events have risen. So now the question then becomes, what are the limitations of these physical models, which hopefully AI, especially the use of foundation models, can better address? So the first thing is that physical knowledge is very incomplete. There's still lots of microgrid physics that we don't completely understand. Running these models requires supercomputers, so there's a reason why only a very few select organizations in the world release weather forecasts. And then there's, of course, very limited repurposing outside weather and climate, even though weather and climate affect so many parts of our daily lives, thinking about its role in agriculture, thinking about its role in energy security, thinking about its role in finance and insurance. So foundation models are actually very well suited to address these challenges. So it has been shown with systems like ChatGPT and DALL-E that as we increase the data and compute, their performance keeps improving in non-trivial manner. Training them is expensive, but now we can run these things very cheaply on our phones. So it really democratizes how we can access and critique these kinds of models. And finally, there's a lot of repurposing that's possible when trying to adapt them for diverse use cases. So in our lab, we developed this model called Climate Plus X, which is the first foundation model for weather and climate. So it's a single model. So it breaks away from traditional machine learning, which would train multiple models for each task. This is a single model which can solve a wide range of tasks in weather and climate. So it can do things like projections. So it can tell you what the climate would look like in decades from now. It could do things like downscaling. So it could get you very fine resolution maps of what the weather would look like in your locality as opposed to a very big region. And then it can do forecasting at very different time scales. So you could think about how it will tell you weather forecast 3, 5, 7, 2 weeks from now. And all of this leads to new capabilities in terms of how accurate these models are. And these models can be downloaded and run on our commodity hardware. So with these kinds of applications, I just want to show you one of the tasks that we did with these kinds of models and the kind of results we are seeing, which are breaking free from the limitations of physical models. So that relates to weather forecasting, a task that we all care about very deeply in our everyday lives. And for this task, if we look at what the current status looks like, there's a mixed picture. So on the x-axis, we're seeing what time ahead we want to make a forecast. And then on the y-axis, we're going to see how accurate the current technology looks like. So if we care about very low timescales, the predominant thing to do is just to predict the present as your future. So a forecast an hour from now can best be done by just copying what the temperature looks like today, right now. If we go to very long timescales, so going in the order of weeks to months, the best thing you can do is just historical averaging. Just look at what weather has been traditionally for the month of February and use that to make a forecast 2 weeks from now. In between is where the magic happens, where we can actually get something non-trivial. And that traditionally used to happen through numerical weather prediction models. So with our model Climate Plus X, we were interested in asking the question, within this map of different techniques, where does AI lie? And we have very good results to show in this setting. So here we are looking at the comparison of our approach with a lot of traditional baselines as well as modern AI models, which do not use a foundational approach like ours. So on the x-axis, you are seeing lead time. On the y-axis, you're seeing the error in the forecast, so lower is better. And we are seeing some traditional ones like climatology, which is the historical averaging. And you can see climatology ends up being pretty good very late, 2 weeks from now. So that's the black line here. Persistence is very good early on because your climate doesn't, or your weather doesn't change so fast. but then it starts becoming really poor as you go to higher timescales. Pangu Weather and GraphCast are two of the state-of-the-art baselines published just last year in Nature and Science, and these really showed the way of how AI can do really well at intermediate lead times. IFS here is what is being used to generate deterministic forecasts as a gold standard around the world. So that's the curve in red. And our approach here in green shows that you can actually extend the frontier of predictability, outperforming all of these approaches by using a foundation model under the hood. So even up till 2 weeks, we are doing better than just historical averaging. And this can have a massive impact downstream if you think about how accurate forecasts enable us to then plan timely responses to lots of disasters. So with that, I'd just like to conclude and also put in a plug for some of our open source efforts in the form of a library called Climate Learn, which will hopefully help a lot of interdisciplinary researchers get into this exciting field of combining AI and scientific discovery. Thank you.
Great, thank you. So we have time for a couple of questions for the speaker, and then we'll bring everyone up. Yeah.
I have a question. When you do the weather forecast, right? Let's say for the upcoming month, and then you go back and analyze the forecast. What's the accuracy percentage? If if that's been that data was looked at.
Yes, yes. So the metric here is the root mean squared error. So it's this, it's in some sense related to the question of accuracy, which makes sense when you have continuous numbers being predicted. And so here we are showing for different variables. So this is temperature, U denotes the wind, Q denotes humidity. So for different variables, we are seeing what's the error in prediction of what it really was versus what we predicted on unseen data. So all these evaluations are done on data that the model did not see during training. So it's some measure of how it will do in the wild.
Okay.
Yes. Could you mention something about seasonal focus? For example, La Nina, El Nino next winter.
Yes, that's a great question, and that's the next frontier that we are hoping to go into. So going beyond 2 weeks to the order of months when we talk about seasons, there is some inherent impossibility there just because the atmosphere is very chaotic. So there are some fundamental limits of being able to say deterministically what would be the temperature exactly 2 months from now at this particular time of the day. But what we can do, and we're hoping to do next, is to give probabilistic forecast, especially for extreme weather events. So saying things about like, what is the probability we're going to see a hurricane on the coast of Florida 2 months from now, 3 months from now, 6 months from now. Those are predictions which we can do with existing techniques, and the hope is we'll be able to do much better with modern AI.
Thank you very much. I'll have all the speakers come up. Just taking a spot up here. I have just a couple questions, and then we'll open it to the audience. So well, wait till it's. Let's see here. And if you have questions that you'd like to submit through the app, please go ahead and do that. I'll put the QR code up again. So the topic of today is research in the age of AI. And so the question I wanted to start with, and we'll actually start with the last speaker because you were kind of headed there already, is about a kind of key change in your research methodology that is coming out because of contemporary AI. So it may be foundation models, but maybe there's something else that you'd like to talk about. And it would be great to hear from each speaker just to reiterate what do you think are some of the methodological changes that you see coming due to where we are right now. And so we'll start with Aditya and then go down the line.
Yes. Thanks, Jeff, for that question. And indeed, I think a part of the reasons why AI has especially enjoyed great interest is because the underlying tech has become very different from what it was. So I mentioned foundation models in my talk. We are using foundation models even without knowing that under the hood, these systems are very different from AI systems of the past. And language is a great example where that has happened, but underneath, there is no particular reason why those innovations should be restricted to language. So part of the exciting developments we expect to see going forward would be the combination of very large data sets, mostly coming from the internet, but as you can see from sciences, they could be coming from the massive amount of sensory capability increase we have had in the last few years, combined with lots of GPU compute. So there's a reason why NVIDIA today is this massive $1 trillion company. That's because the computation hardware they're building specifically caters well with doing AI on large scale data sets. And then at the core is also algorithms, which a lot of people in my field work on, which can combine these data sets and compute to build very general purpose systems that allow for flexible adaptation. So that's a big moment because we all have our own use cases where we think AI could be relevant, but having to do all the data collection and the large scale compute training is not within the means. But the adaptation part is really lightweight. People even call it fine tuning. So that opens a lot of possibilities for a lot of us to be able to do very creative applications of AI on top of these existing models.
Thanks. Janie, do you want to go next?
I'll be brief, and I'll just say that we're doing economics, statistics, and data science research for policy impact, and the data sources that we work with don't really lead to massive methodological changes with the changes in generative AI that have come over the last year. They could very well. I think we're more focused on the actual policy questions around generative AI and how they intersect with our fields of focus, particularly education policy, labor market, workforce development. I think we're going to see massive societal shifts in who has access to what jobs, replacement of language, knowledge workers, all kinds of things that I think we're trying to think, from the perspective of government and policy, how to understand impacts. So I'll say that, and then I'll just conclude by saying that we're also dealing with this, as everyone is in this room, as managers and trainers of young people, right? So we have a lot of people that we're training to do research for us, and learning how to code and trying to understand how to do that well and use these new technologies for efficiency just in our day-to-day work life.
The part that was most helpful was trying to connecting the physics and the machine learning learned. So physics is a physics-based models or physics-informed model, or getting some emergent physics law using the data set. But I think I have to emphasize that we cannot replace humans' work on the ground, to be honest, especially in the geologists. You can see on the Montecito examples that there are big boulders coming in, and because of their travel so far is related to fine-grained sediments. But some of those scales cannot be detected from the remote sensing data set. It actually helps us to where to go and where to look for and what to look for. That kind of information we can learn and more. Yeah.
Thanks. So one more question for me that's a little bit of a follow-up, I think, to that, which is how you work with either your students or stakeholders or your funders to talk about the relationship, the challenges of looking at causality or the why behind the outputs of these models. And so I'm curious, each of you maybe touched a little bit on that, but if you could talk a bit about how you help people understand, the ones who are doing the research or funding the research or using the research, the sort of maybe restrictions and possibilities with respect to causality. So maybe, Solge, we could start with you and come the other way.
So the part was harder for especially the landslide predictions. When the big rains come, everybody says that the threshold is higher, then there is highly likely. But actually, we do not know where it happens. The prediction, when you look at the map, all of the mountains has high probability of the landslide, and which hollows will be fail, which will be false positives are so high. And most of the models, the problem is there's so much high false positive, and understanding and giving some information about the uncertainties of the models. And it doesn't mean it will not happen, but also giving a false warning also jeopardize the credibility of the science. So there is a fine line to walk in that sense.
I think I'm going to answer this question. I'll just say that when you speak to a funder who's interested in solving homelessness in LA, or you speak to a partner and you say we can predict this outcome, they think automatically that you can explain why it's happening, or that you understand from the predictive model what the causes are. So we've had to do a lot of co-learning. A lot of the people that we work with are social workers or case managers or executive managers of public agencies, and help them understand that machine learning models and features are not risk factors. It can't be reverse engineered to a questionnaire or explain what's happening. And I think just to take a step back, I often give a talk that's for a general audience around what is causing homelessness. And to state the obvious, what is causing homelessness is a massive housing shortage that is increasing our housing costs along with stagnating or declining income. It is a problem of economic justice, right? So looking at mental health system and jail contacts is helping us predict something, but it's not explaining the root causes of homelessness. And so I think doing this work in partnership with public agencies over so many years and our funders, we've tried to develop a group of people in LA who are a little bit more knowledgeable about what these things mean, what these terms mean.
Yes, I'll be a little contrarian on this question because it's very interesting, but I also feel it has multiple dimensions to it. So I asked this question in my graduate class that if, let's say, you were a farmer or even an everyday citizen who looks at weather forecasting, how many of you would prefer a highly accurate model which tells you precisely with a lot of accuracy whether there's going to be a hurricane at your favorite travel destination when you plan to go, versus an explainable model which is not very accurate but gives you a lot of reasons as to why there may be a hurricane or not? And the answer is, of course, most of the people go towards the farmer setting where you prefer some model which is more accurate. But if you change the domain, now this, instead of your travel planning, just make it some diagnosis about a serious disease, suddenly this population also changes their answer. You want to know why you should probably get a procedure which could have side effects of its own before you elect to do it. So this question of explainability in the context of AI is important for many scenarios, but not all. And the reason why I even draw this distinction is because the methodology for explaining AI has its own can of worms. There are lots of techniques for designing explainable AI techniques, explainable AI models, but many of them have been shown to give explanations which are not exactly how the model is making its predictions. You use a different technique, you get a different explanation, and then this question becomes of how you're going to do good science with these kinds of techniques. So that's why that is not to say we should stop doing research in explainable AI. In fact, we should double down on research in explainable AI. But then we should also accept that what are exactly the scenarios where we would be happy with black boxes which are more accurate but not explainable. So that's my also perspective on explainability, also connecting very deeply with the same kind of questions of causal inference, like why does the model make a certain prediction?
To see how contrarian this is, does anybody want to respond?
I think that it's actually very interesting points that why do we need to do. I got also a lot of questions. I'm doing the physical models. Why do we need to do physical models if you do have AI can predict much better? But I would say that the data that we have right now, it may not be the same data we got in terms of climate change. For example, that climate change we experience and the data that we have, we never know how it will change in the future, and we do not know how does that change if the precipitation somehow exceeding the levels that we never seen. So in order to better prepared and better predict, we need to have a better understanding on the physical models, or improving the physical models will give a better prediction in the future that we do not have a data right now. That's why I think I'm having some interest in connecting those two to have better models, but also by improving the physical model, they're allowing the input value that we never have it data on will give more predictions. But you're absolutely right. There are many explainable model AI models, and then the finding that we found on the paper, you're basically similar to what we submitted to Nature and rejected, and the reviewer saying, oh, you found the precipitation and slope is the best one. We already know this. That was their answer, or that was why that devalue our finding. But it's important to find, to somehow, some way to validate the physical understanding we have through the data. That's, that was our argument, but yeah.
Great, thank you. So the first question from the audience was somebody who was interested in hearing about Ricky's experience, so I'll put that up, Janie, if you're willing to talk a bit about that, and then we'll take maybe a question or two as well from the audience.
So again, Ricky consented to us sharing his story. I just think it's a really interesting and humanizing explanation of how some people experience housing instability in our region. So Ricky was a handyman for much of his life, and he had an on-the-job accident and ended up filing for disability and not being able to work. And he lived in a one-bedroom apartment and was basically able to subsist month to month with his disability, supplementing his income. His children were unable to care for his grandchildren, and his ex-wife had been caring for them and passed away. So Ricky suddenly had 3 minor grandchildren living with him in his one-bedroom apartment. If you're an economist, you think of this as an economic shock, a really dramatic one, right? So a household of 1 went to a household of 4, and you also have a lot of stress on the living situation. And they had been on public benefits and had been somehow, those benefits had been canceled, and that was the moment at which the unit called Ricky. Ricky agreed to enroll in the program. So they were able to buy different furniture for the apartment, and most importantly, they were immediately doing benefits counseling, how to get this family back on all of the benefits that they qualify, particularly for food security, and have been counseling Ricky on through housing navigation to basically try to get subsidized housing with slightly more room. So it's just a counterexample to the one that I started with, and I think an interesting example of who these clients are.
Okay, so we have a moment for questions, a question or two from the audience for this group. Okay, oh, yeah, one more in the back, go ahead.
So we kind of, there was a discussion on like public benefits and stuff, so maybe a little unrelated, but is there a way to kind of through using like AI models to try to get there is like some public benefit abuse and stuff, like will AI be able to help with that, those kind of cases?
I would assume that someone is thinking about that. We're actually working with the LA County Department of Social Services not to detect benefits abuse, but to try to help individuals who are on certain public benefits programs receive more housing assistance. I think from our perspective, frankly, the abuse is fairly rare, and the families in these programs are really in very dire straits. I mean, it's hard to emphasize the average household experiencing homelessness is earning just under $10,000 a year in income. People who end up being screened and eligible for benefits are usually, they go through a lot of screening, and I think fraud rates are relatively low. And also we might all agree that most people who are screened into these programs really need financial assistance given the state of our economy. So there are people doing AI projects. The ones I'm more familiar with are actually trying to predict abuse for families involved in the child welfare system. But we're not doing at the California Policy Lab that kind of AI or modeling. We're more thinking around how to bring more people into the safety net.
Thank you. If there's no, oh, all right, one more. Up there.
I'm curious about the policy aspect. I think a lot of people think of these models as sort of magical or giving us all this incredible information. And I'm curious if the policymakers maybe are less like skeptical of the results that are coming out of these models, or if there's been like any sort of different reaction, like, oh, the model said this, so therefore it must be true and we're just going to buy it. I'm just curious if you've seen any patterns like that or any differences in how people are reacting to the information that these models are giving because they're from AI.
Yeah, that's such an interesting question, and I don't know. We haven't tried to collect data on that, right? That's actually, I think, an interesting research question. In the context of the project that I described, there's a piece of information that I didn't have time to share, which is that the way homelessness prevention normally works is that people self-identify as being in need, and they call a provider in their community and they try to get assistance that way, right? So that's a very typical way we run government services. You wait for people to say, hey, I need this, and then they go in, and if they meet the eligibility and other screening criteria, they might get cash assistance that way. And so if you think like a policymaker, we know that certain people are able to do that and other people are left out of that system, right? Because they're not able, for whatever reason, or not trusting enough to navigate their way through all of that bureaucracy. So I don't think that our partners, at least several years in, think of the model as magical. They just know that the people they're getting are otherwise being left out of prevention programs. And so they see it as an additive or complementary solution. And I think they're really curious to see whether it works. I mean, they authorize an RCT because they want to know, is this actually doing what we think it's doing, right? So there's I think, healthy attitude towards, try something innovative, but really figure out whether it's working and whether it's worth investing in. The last thing I'll say that might sort of touch on what you're saying is that if you think about traditional programs, a lot of that screening that I described that's really time consuming for the client is about fraud prevention. To go to the last person, you don't want to pay someone's rental assistance if they don't actually qualify for it, right? And so they have to do a lot of paperwork. And one thing that's interesting about the psychology of a predictive model is that if we're sending them these people and the AI is saying, hey, these people are really high risk, they don't have to do that. They're serving the client within hours of making the phone call and enrolling because they're pretty confident that this is a person who needs help. And so they don't have to do all of that. Well, show me your back rent and show me your lease agreement and show me your eviction notice and some of the stuff that we made people go through. So that's been a really interesting feature of this, that like they're giving them food cards, hours after they enroll because they're confident that this person is the right client for the unit. So.
Great, thank you so much. I'm being told we should wrap up, so if we could thank the speakers. And next up is the break, I think.
Yeah, we have a very short break, and please come back because we'll have an engaging, interactive discussion with the audience. So it's your turn to ask and answer questions. So please come back in about 15 minutes. Topic, which is implications of AI on research, and this is an audience discussion. So this will be for everybody. I also wanted to, so this will be hosted by myself and Oscar Leung, who I'll let introduce himself, and I'll also officially now introduce myself. So I am Deanna Nadell. I am a professor in mathematics, and I'm also the executive director for one of our sponsors today, Institute for Digital Research and Education, IDRE. The other co-sponsor is, of course, DataX. And we've got the privilege of having the Executive Vice Chancellor and Provost Darnell Hunt with us. He stopped by, so he's going to say a few words about DataX as well before we jump into our discussion.
Oops, excuse me. Thank you so much. It's great to see everyone. So AI, very important development. I'm really looking forward to the discussion today. For those of you who don't know, there's going to be a UC-wide Congress on AI on the 29th of February. And one of our own, Sophia Noble, will be engaged in conversation with me around some of the societal implications of AI. So I encourage you to join us. So just want to say, I'm really excited about this work here at UCLA. I'm excited about DataX and the direction that it's taking. We have 4 faculty directors now who are leading the various pillars: fundamental data science, applications of data science, and data justice. So I think we're going to do something unique here at UCLA, and I'm really supportive of that. For those of you who don't know, we talk about the DataX initiative in our new campus-wide strategic plan. You can Google it. It's just strategic-plan.ucla.edu. It gives a pretty good overview of how DataX aligns with some of the major goals of the university. So with that, I look forward to the conversations. Great talking to you, and I think there's going to be a lot of important work coming out of this initiative. Thank you.
So I'll let Oscar introduce himself, and while we're up here, if you haven't already, please scan the QR code and start entering questions, thoughts, and we'll then start the discussion sort of based around those pillars.
Awesome. Thank you so much, Deanna. Yeah, I just want to quickly introduce myself to you all. So I'm pretty new to UCLA, not actually officially here just yet. But my name is Oscar Liang. I'm currently a von Karman instructor in the Computing and Mathematical Sciences Department at Caltech. And I'll be joining UCLA this summer as a tenure track faculty in the Department of Statistics and Data Science. And I'm really excited about that opportunity. And it's a really pleasure to be here to co-moderate this audience discussion on the implications of AI in research. And so kind of the goal of this discussion is, you've heard a number of wonderful talks talking about the ways in which AI is being used at research here at UCLA and what are some of the various issues surrounding AI. And we wanted to take this time, because we have so many folks from a diverse number of backgrounds, we wanted to take this time to be able to ask questions, but also to be able to respond to questions from the audience. So we want to sort of maximize the audience participation on these various topics here. And so I just want to encourage you to feel free to scan this QR code to start adding questions to VVox, and then we'll start discussing those in a little while. And so while you're starting to think about what types of questions that you want to ask, I kind of want to just try to set the stage and talk a little bit about what are the types of maybe questions and what's really the focal point of this discussion. And so obviously we're all here because of the transformative impact that AI has had on our workflows and on research in a number of domains, from science and engineering, and it's obviously really captured the attention of the public. And we've seen a number of great examples of AI in action in terms of climate science and economics and medicine as well. And of course, with all of these successes of AI, it brings a number of different challenges, right, in terms of either integrating AI into research or also just fundamental AI problems, right? So things relating to, for example, mitigating AI risk. How can we ensure guarantees in which malicious actors won't be able to change, some of these deep nets when you employ them to solve some particular task? And also various things around data sets and privacy and biases. The opaqueness of the data that's actually input into these models makes it challenging for us to really understand what are the various biases that they could potentially be reflecting when used to solve some particular problem of interest. But I think really the main focal point for hopefully today's discussion is in regards to UCLA's position and role in this sort of endeavor in understanding AI and AI's implications in research. As a university, an incubator of thoughts and a place where we're teaching the next generation of students who are going to be impacted by AI, use AI, and potentially create AI as well. It really is sort of important for us to think about the ways in which we integrate AI into our research and how do we actually become, really leaders in this field. And so this, of course, covers many different types of facets. So for example, what are the ways in which we can ensure that UCLA becomes a leader in AI research, right? So whether this comes from more funding in terms of computing capabilities, right? Or in terms of trying to ensure we have interdisciplinary activities in order to allow folks from various disciplines to come together to use AI in their work and to better understand AI itself. And I think one other aspect I think is quite important that could be also a focal point of today's discussion is AI in terms of the education of our students here at UCLA, right? So asking certain questions like, we have, for example, recently this novel data theory major for students to integrate, mathematics with data science to prepare them for this world full of data science. Should we, for example, consider things like an AI major? Or how or what are various ways in which we could potentially integrate AI into the classroom in a positive fashion? So these are the types of questions hopefully we might be able to discuss a little bit today. I just wanted to sort of set the stage and maybe get your minds turning in terms of what types of questions you might want to ask and what types of things that you might want to talk about today. So with that, I think we want to maybe start off with some initial questions.
Yeah, and also feel free to upvote questions. This is a democracy, so I think a lot of them have a couple of votes. Yeah, we can start with this first question. From your perspective, what are the biggest challenges related to AI that we, the collective we, have to tackle? So do folks have thoughts on this?
Go ahead and spend a few minutes entering in your responses, maybe not a few minutes, a minute entering in your responses, and we'll show the results, and then we'll open it up for audience discussion.
So please type this into the app, and also if you have something you'd like to speak, feel free to raise your hand, and we'll pass the mic around as well. Anyone want to kick us off with a oral thought while people are typing in some thoughts? Or if you don't feel like there are challenges to tackle after today, you can say that.
AI is solved.
Sure, I can say the speed of change. That's huge. I don't know if you want me to. Okay. Yeah. So there's so many things that it can do, and there's so many things to be concerned about, and there's so many ways it's being used, and it is a challenge to keep up and to know where to start to actually use it properly, use it for a benefit, while also understanding the challenges of it, the security challenges as well, and also to how it's being used, for instance, in cybersecurity now, and also elections and things like that. And so it's so big, and how I guess my big concern is just how do you just control, take control over it and use it for the benefit of society, basically.
Thanks, Davida. I'm going to go ahead and close the poll so we can see. Okay, maybe this will continue to fuel the discussion.
We didn't get GPT out here to actually summarize this for us, so you have to do the reading yourself. I know, it's tragic. Other thoughts or responses to both what Davida said and also what our beautiful word cloud seems to be showing us? Or just thoughts or comments in general, sort of around this topic? You, Tom?
Yeah, I think a big problem with AI that I think I still am curious to know if people have opinions on or ideas on how to tackle is like, a lot of people in this room are very technical, and we understand like AI, like what that means to us, or like what optimizing a model, or like we're just fitting parameters to something. And so to us, or like to more technical people, we kind of know AI isn't this black box of magic. Like it's just these mathematical tools that we can use to understand data better. But how do we explain this to the general audience? And then kind of like, maybe these aren't the most complicated things to explain to someone that's non-technical, but how do you kind of explain these to, anyone can open ChatGPT and just type whatever they want in and get maybe something that they could see as a meaningful answer, but they have no idea what's happening inside of that black box. And maybe or like AI literacy maybe, or some sort of, how should we teach our students or like youth about what AI is or what it means? I think that's like a big problem that we should think about.
Yeah, I personally really like the phrase AI literacy. I think that sparks a lot of questions for myself. Do you or other folks have thoughts on how to combat that? And if you also agree, yeah, in the back. Terry.
I think one of the biggest skills we're going to have to teach students now is how to independently verify statements. I mean, there's going to be so much misinformation, and so AI generated not reliable information, and so like one thing I know that some teachers are doing, for example, is giving homework assignments where here's a question, here's ChatGPT's response to it. It's wrong. Can you figure out what's wrong with it? Can you critique it? Can you convince GPT to fix it? Things like that. So there are ways to use AI's technology to actually strengthen students' ability to critically think, and this is going to be essential.
Markup print?
Yeah, kind of riffing off of both of what you said, I've actually used it in classes before for teaching, and I think one of the problems is how the students are using it and approaching it as a tool that can be used much like we would use like Wikipedia, and how, I don't know if any of you are old enough, like when Wikipedia was first used in the early 2000s in college, and people were saying, oh, how are we going to use this as a terrible resource that's going to destroy education? How we can use AI as a toolbox, as something that is integrated into our teaching when we're doing things like humanities or essays or even math or basic coding. How can this be a tool that's used, that's effectively used, and not just, oh, I'm putting it in and walking away from it?
So I'd like to address a little bit Oscar's original question about how UCLA can be a leader. So in my experience from IPAM, UCLA has a very good interdisciplinary culture. But what's needed now is to build a community. And to build this community, first of all, you need to hire faculty. I mean, Roger Wakamoto mentioned that Wisconsin is hiring right away 30 faculty. We need to do that. We need to create the social capital that links people between different disciplines, the people with the good problems and the people with the good solutions to them. And we need to build up a whole ecosystem educationally. So data theory is wonderful for the people who want to learn this much AI, but we need to have, there's so many possibilities for departments where there's a strong disciplinary knowledge plus what was referred to as data literacy, but some level of fluency with data science and AI. So I think building this community is really the underlying challenge. And so that's what I would say.
Awesome. I think that's a great point. I just want to piggyback off of that in terms of a potential idea for something like this. I imagine, I think I've heard of different types of degrees that are, like your favorite subject plus X, right? Where you sort of add an additional component in order to illustrate how we can use this component in, say, biology or law or something along these lines. So I wonder if there's some way in which we can create degrees or classroom experiences where it's something along the lines of your favorite subject plus AI. Like something along those lines where we talk about what are the problems at the intersection of AI and law, what are the problems at the intersection of AI and anthropology, AI and medicine, all these sorts of things. And I think that also gives us a way to have faculty from different disciplines come together and to talk about how would we even create a class like this? Like what would that sort of even look like? What types of resources do we need? So that could be maybe one type of thing that could be interesting to think about.
And from that point of view, it's not new, right? As some of the math postdocs in here and grad students who teach PIC courses can attest, a lot of those courses are filled with students from other majors who want to add programming to their major, right? So like this has existed for a while. So we need to now just adapt to the new programming, I suppose. So I think the infrastructure is there if we can build that into the curriculum. I think I saw a hand, yeah.
So something that's probably a little bit different is probably one of the biggest challenges, at least I see, is hardware. So as a lot of these AI models, a lot of these data sets become larger and larger, the need for more hardware, and especially more complex hardware, is going to start exponentially increasing, in which we probably would, the amount of production of GPUs, data storage is probably going to be very demanding, and we're probably going to need to develop either more big data type of tools in which it can probably combat or at least get a lot of these models to be a lot more scalable. So we probably need to do a lot of research into actually not necessarily using the models that are already been developed, but improving on it. So to become AI can be a little bit more scalable when it comes to running, training, and fine-tuning the data.
I'm going to move us to the next poll question because I think that it follows the thread of conversation. So if you refresh the app, you should see a new question that you can respond to, which is, what resources does UCLA need to better situate AI research for the future? Does anyone have a response that they want to answer verbally? Or should we see the results?
Maybe we can check out the results.
I'm going to close the poll. I'm sorry if you're still typing.
I think we see a theme. GPUs.
Lots of GPUs.
I might, to get us started on this, since you're joining UCLA very soon, what resources, say, for your own research do you need? And when you came here, was that part of the discussion? As a new faculty member, I think your perspective could lead us off.
Yeah, definitely. I think that lots of GPUs was definitely very much in the discussion in terms of resources that I would need. And one thing I think that I've sort of been curious about in relation to this question is, obviously with a lot of these extremely large models, like, a lot of the actual groups that train these models or have created these models that can train them at scale are these large tech companies, right? And so I wonder if there are ways in which, we can potentially strengthen partnerships with certain companies. So I know that, for example, there are a number of faculty who are work closely with Amazon. Like, if there are certain ways in which we can leverage that relationship in order to have faculty have access to, more computing power and certain things like this. That's just one potential idea along these lines. I don't know if anybody else has additional thoughts on this question.
There are a lot of resources, computing resources provided by NSF and DOE. I wonder how many people use those from UCLA.
You mean the existing resources, not applying for
Yes.
some?
And lots of GPUs, lots of specific hardware for AI, ML, those are available.
Since the mic is here, I also want to add that GPU nodes for the Hoffman 2 clusters. I don't know how many of you, of course I work for it, so I'm invested, but we do see that there is a lot of utilization, and sometimes it's hard for us to satisfy all the need. And so the campus could think about contributing to it. So
Does anyone else have additional thoughts that they'd like to share?
So everyone's got their resources, they're good to go, they don't need anything. I mean, just looking up at this, I see faculty, courses, more classes. I think that's a second theme here. So besides the physical infrastructure, the hardware, also having more of a culture, more offerings, more humans. And I think, you know, again, Roger opened or at the beginning of today with this discussion about University of Wisconsin hiring 30 faculty in the next year. Hopkins, I think, has been mentioned as well by Eleazar, hiring like 150 faculty lines just in the College of Engineering alone. So I think that that's a resource theme that I'm seeing here as well, both on the human side for more of the actual research. Other thoughts or questions along this line?
I think there's one additional resource that's somewhat related to this that no one actually put it up here, is data. And so I think that it might seem obvious, well, there is a lot of data on the internet, why aren't you using that? But I think that in order to, for example, there's a number of different scientific problems that have interesting data that maybe, for example, AI researchers have not had access to or have not tried to actually apply certain models to them. And so I think it could be interesting to think of ways in which one could, in some sense, advertise their data or talk about, you know, we have this really interesting problem. We're interested in using a machine learning type of technique to it, but this data is something that we're currently, you know, harvesting. We're trying to see what types of technologies can be applied to it. And so maybe that could be one thing to sort of think about is how can we better sort of in some sense advertise or understand like available data sort of on campus and folks who are interested in using AI in their research.
So the next question is, what interdisciplinary activities can UCLA organize to generate greater synergy and make us leaders in this field of AI?
And feel free to be specific.
Oh yeah, sure. We'll probably wait for like 2 seconds and then we'll open up the mic. That's fine.
We have a hand, Oscar.
She was going to go first. We're just going to wait for the poll.
Okay.
And then
Feel free to chat during the poll. I think we can multitask here. That's okay.
Sorry, brother.
Okay, so during a lunch break, I talked to Mark Green from IPM, and he mentioned to me there is an idea to make a research portal, and as well as educational portal on these topics. I'm not sure it's in DataX or at UCLA, and that would be great. You know, especially like for soft money researchers like me, to make connections, you know, with different researchers across sciences. Yeah. So, thank you.
So, you know, I think given the way that the symposium today was organized, really encompasses this question in many ways. You know, in the beginning of the day, we heard all these very creative and innovative ways that we can deploy AI in research. But one of the things I think we need to discuss is this race to technological superiority, whether it's macro level, international, or locally, has sidelined some of the most important questions. And of course, this is also has to do with alignment crisis, but it has sidelined the questions of morals and ethics. And one of the panelists earlier today had this phrase of, you know, in the technical side, we always ask, can we do this? But I think we should have more people asking, should we do this? And I think the interdisciplinary approach to looking at AI is very critical at this very pivotal moment. And so I just want to sort of highlight the question of should we do this? That should always be part of further advancement. That's all.
Yeah, thank you. I completely agree. And luckily, our next session after this Q&A is the data justice session. So I think there will be more of those types of questions during that as well. But yeah, I completely agree. It's a great point. So some of these I find very interesting. So if you have written some of these and would like to elaborate, I'd love to hear more detailed thoughts.
I put PI matching, which looks like pie matching, which I'm sure confused people. But trying to think of a way to do like they do, for instance, in the startup community, where they'll have mixers where people with, co-founders are sort of brought together to pitch to each other their sort of projects and, what the data sources are that people are working on, people who are looking to apply new techniques, maybe have more opportunities to bring them together, offer some pizza, and see if we can do connections.
I'll just second that one. I've been speaking a lot with OCGA and the Limited Submissions Office to do precisely this, at least for limited submissions, but it'd be great if it could even be more broad. So I definitely hear you, and I hope that we can get something like this going. And I think that also had to do with the person who spoke over here in the middle with the research portal as well. Completely agree. Yeah, go ahead.
Yeah, I agree with Professor Gorling. I was thinking maybe something like Coffee Meets Bagel, so you could put your profile, or Tinder, and then basically an easier way to match, right? So if you put what you're looking for, and then rather than having a portal which is difficult to navigate, having an app would be simpler. So then you really quickly match people who have common interests, and then get some of these ideas going.
As long as there's gluten-free bagels as an option for them. Is someone up here? Nope. Yeah, TV.
So there is a website, profiles.ucla.edu, but that covers only the faculty from medical side. I think this, where on this website you can search the people with their specialization. And there is no website or no portal where you can search the whole UCLA faculty with some specialization. I think the first step should be that expand that facility.
We are at an AI symposium, so what are folks' thoughts on using AI to do this matching and possibly even faculty research summaries? Are we pro this? Are we con this?
Yeah, granted, I don't know if this is already kind of being done, but especially if we have, a lot of experts here, work on, actually making policy briefs, making, policy decisions, working with lawmakers, especially if there's going to be policies dealing with AI ethics, and that can probably, if we have, experts already here, kind of putting, especially like UCLA, as leaders in forefront into some of these decision-making to lawmakers.
Thank you. So from a graduate student perspective who's working in interdisciplinary areas using AI, I think UCLA courses should be more democratized, because right now, for example, if I want to take a course from computer science which is related to AI, I cannot get a PTE or permission to enroll. It should be available to all, at least graduate students who are working in this area. Thank you.
Maybe we'll kind of switch gears and move to the questions posed by the audience. I see a lot of questions here look very interesting. And I don't know if Mayak is here. I wonder if you might take a stab at this question here in the middle. Will there be a ceiling to human knowledge created by reliance on AI data crunching rather than new knowledge or intuition insight? I feel like that might be up your alley. Do you want to take a stab?
I think that, by analogy, has happened long ago, right? As Terry was pointing out during lunch, that when calculators came, we lost our ability to do mental arithmetic, but on the other hand, that opened up our mental abilities to do all kinds of numerical experiments, which we now call simulations, without which we can't live. So I think this, at least on the positive side, like everything else, it's possible that when, like many of the things that we want to get done right now, when I go to find a publication that's relevant for my research, 30 years ago, I had to walk all the way to the library and go through the deck of cards and find the paper and so on. Took a long time. These days, I just click and find some PDF. But in the process, I was thinking along those time that I was walking to the library about the problem, maybe at least 10% of the time. As I was walking to the library, I was thinking, how will I solve the problem? So both pluses and minuses. So I think the same thing is going to happen. We'll be able to find relevant research more readily, but on the other hand, we might stumble less frequently on related research. We need to, because that's how human beings have made progress, is to stumble across something random, and the best example being this meeting, where we stumble across the work done by each other. So I think it's something at the level of the mind we can imagine. The real challenge is to imagine at the level of the brain. Because when we start reaching kind of human-like behavior, that's something else altogether, right? If it's a journal article which is in PDF format, which is printed format, it's different and it's not so different. But here, the difference is massive, as how our thinking patterns will change right from the ground up. And all we are thinking about is right now with the existing AI, but as the newer versions come in, which are interacting with us, which take word prompts, which can respond using words as well as images and videos, which is already happening, that's a direct brain AI interface is created through our eyes and ears. And that's a whole different experiment. So who knows?
You had another one over here. Two.
Okay, I'll take a crack at this as well. In my experience, great experiments have been what have really created turning points in human knowledge. I mean, there was, for example, a beautiful lecture that Barry Barish gave about his work detecting gravitational waves. It's one of the greatest experiments ever. But these key experiments have really suddenly changed how we see things. And I don't think AI number crunching is going to replace that. I think if we find out how gravitation and quantum theory work together, it's going to be through some crucial experiment. And I think the limits to human knowledge are really not there. I think what AI is good at, to me, the reason that semi-supervised learning has worked so well is that, so this is where, right, you have some labeled things, but mostly you're just exploring what's out there, is that machines are very good at detecting relationships that we don't detect or even have words for. And often that's how it allows it to classify things that we can't classify. That sort of knowledge will expand extraordinarily as AI takes off. And whether we'll ever have words for these things I don't know. But there's no substitute, at least in science, for these great experiments.
Yeah, I'd like to point out how there's this proclivity to think that we've been here before with other technological innovation, and that it's just a rite of passage for humanity, and that we'll get over, we'll go through it, we'll overcome. But I think it's important to know that never in the history of humanity have we created autonomous technology where you can do autonomous thinking. I think this is something that is unique, and the more we optimize this technology, there is a lot of danger. So that's all.
Thoughts or responses to either viewpoint? Remarks? We've got about 5 minutes left. Maybe we just scroll through. Is there an upvoted question that looks? I guess we've sorted it in an odd order. Huh. If anyone wants to comment on hyperscalers, please feel free. I think a lot of these are all very interesting, and I hope the point of today is to start the discussion. So I hope these discussions will continue, but maybe this one has 4 upvotes. So to faculty and students in the room, how can staff and technologists best meet your needs and address your questions around AI? Any thoughts there? Over here.
Hi, yeah, so my name is Joy, and I pose this question because I work in the social sciences, and I'm in charge of kind of an innovation studio there, and we started late 2019 to kind of try to foresee the needs of our staff, our faculty and students, and so I just wanted to ask and see if anyone had any suggestions and what we can work on, maybe putting together that kind of AI literacy program and making that available to our students.
I'm not sure if this ties back, but I did notice one of our word clouds, like campus ChatGPT was on there. So I don't know if any folks have comments on this, whether that would be useful, whether that's a reality, or other resources or things that folks could do. We have one behind. Oh.
I have a quick and easy answer, which is GPT-4 access. As a grad student, can't really afford it myself, so.
So, as a basic researcher in molecular medicine, so I guess to me, because I'm not basically in computational background, and I would like to use some of software published daily on some methodology journals. But to me, if AI can help me to most efficiently to pick up which is the best software I can use in my specific domain or questions, that will save me a lot of time, and that will give me best practice for using. I will get most beneficial from the AI application. Thank you.
Have you tried doing this already?
Yeah, I have tried doing this. So I have using several software, compare with them. Initially, I will ask AI which one is appropriate I can pick up. And then I will narrow down to what is the best version I need to use. And then it will give me some suggestions. But still, I need to evaluate what is the best solution by myself. It seems like that I need to give feedback to AI as well, and then most cheap and the best combination. Thank you.
Okay, I think we're right at the mark. So we're gonna switch gears. And again, I hope we keep these questions coming. Hopefully we will see each other's faces and names and be able to continue having these discussions. And we're gonna lead into our next session, which is the data justice pillar. And do we have Ramesh here? Oh, yes. Great. And if the panelists are here as well.
Test. Perfect. Okay. And I'll stand over there. Is that what you want me to do? Sit. Okay. How are you? How are you doing? Good to see you. That's okay. I'll fill you in on how things are going. It's good to see you. Yeah, of course. Of course. Yeah, it's totally fine. Yeah. And I'll be shooting questions to each of you. All right.
I guess we clear the room when we talk about social justice.
That's what I was just about to crack a joke on it. About the same thing. All right. Well.
We know who the real ones are.
Go ahead. Yeah, you can introduce me. Go ahead. Yeah.
Let's just hope that they're just getting some water, and we'll be right back. I'm very energized. So this panel is moderated by Ramesh Srinivasan. He's a professor of the Department of Information Studies and the director of the UC Center for Global Digital Cultures, and the assistant director of Community Engagement and DataX. So thank you so much, Ramesh, and the panel as well.
All right. Can everybody hear me okay? Okay. So I'm so excited and honored to welcome my dear colleagues here to join us in a discussion about, I think, some of the most important issues driving artificial intelligence and data more generally, which are questions of how can we foreground ethics and values first and foremost as we think about and conceive of technologies of all kinds. So, my story on this, I'll just introduce this topic for 5 minutes and then we'll get firing. I have a lapel mic, yeah. So you can't hear me, so, all right. Okay. You all can hear me. Okay. Yeah, I'm mic'd, okay. Let me just go here. All right, so my story with this starts about 20 or so years ago when I was a graduate student at the MIT Media Lab, a student of Marvin Minsky's. And in that class, Professor Minsky was sort of teaching us some concepts around artificial intelligence. And I found, while I was in his class, I was really wondering, why is there a certain kind of restricted idea of what AI is, in a sense that it was very limited to rationality and cognition. And so I asked Professor Minsky this question, while I was in class. Well, what about emotional intelligence? What about creativity and intelligence? What about irrationality and intelligence? What about non-humans, like distributed groups of orcas or birds? Do they exhibit forms of what we might call intelligence? And Minsky kind of laughed me out of the room when I said that. And that actually really embarked upon a path that I think is really important that all of us are aligned on here in this panel today, which is really to look at the biggest questions of what we mean by artificial intelligence, which is a term that's thrown around quite widely. But what do we mean by intelligence? What do we mean by artificiality? And asking those questions, especially in an era where datafication, big data, patterns where almost everything in our lives is transformed into some sort of digital footprint or source of data that can be calculated, computed, potentially stored, aggregated. What does that mean on a planetary level for all forms of life, especially human beings? That's the biggest question, I think, that at least drives my inquiry into this, and I think we really share this interest in this panel.
because when we're talking about so-called generative AI, we're actually talking about patterns in data that are being gathered from all of us at all times, pretty much no matter what we do. Right? And so that, I think, is an important issue that many of us must take note of, right? When we're using our credit cards, it leaves digital footprints. When I'm picked up by a surveillance camera, it's leaving a digital footprint, right? All of these are forms of data that are being calculated and computed upon. And so I think a big question that I would just want to put out there for us to just think about, what should not be datafied on this planet? What should not be calculable? According to whose vision is calculability occurring? And I think this is important because we're at a moment in AI where private power, corporate power, the powers that have already made social media quite destructive, in my mind at least, are now taking over the forces of AI and the discourses and the ways we understand AI and conceive of AI. And I just think we can do a lot better than that because we're seeing spillover issues when it comes to discrimination, violence, and bias. We're seeing huge planetary issues when it comes to labor and the gross inequalities we see in a datafied economy. And all of this, to me, presents an opportunity not to necessarily be traumatized or angry or upset, though I do feel some of those things myself, but to actually ask questions about what type of world we wish to live in and what does AI mean in relation to such a world and such a planet. So that, I think, is really what this panel is about, in my mind at least. I'm really honored to welcome my colleagues to join me in a conversation on these issues in this panel. We all have different experiences with artificial intelligence, and we'll be touching on issues tying to bias and discrimination, labor, regulation, safety issues, and the whole discourse around AI safety, all to not necessarily sort of solely raise problems, but to ask and conceive of huge questions around where we may want to take artificial intelligence, in what ways, with what scaffolding, with what sort of checks and balances, and really in whose power, right? Who is driving these technologies moving forward? I think those are the big questions that this panel is focused on. So instead of it merely being a point of critique or saying, oh no, we built these technologies and it's breaking all these things, which is essentially Facebook Meta's business model, right, among others, and sort of dealing with the harms after the fact, let's conceive of aspirationally the type of world and planet we live in that is built on ethics and values, and think about technology accordingly. And I think that's what I want us all to together think about, ideate, design, imagine, and create. And I think here at UCLA, we have a huge opportunity to be the leaders in exactly that space, which is why I think data justice and equity is such a central part of what DataX is, can be, and should be all about. So with those few words said, I'm really excited to introduce my colleagues, and I'm going to sort of ask each of them initial questions. But first, just briefly, their bios, of course. Their full bios are in the program that all of you have, I hope. But first, I want to introduce my colleague, Shahzada Ahmed, who's a UCLA Chancellor's postdoctoral fellow at the UCLA Center for Race and Digital Justice. For all of you who don't know of this center, this is a really important center doing important work that, of course, my colleague Sarah Roberts is involved in. But Shahzada is a researcher in information studies, a Chancellor's postdoctoral fellow here with a PhD from UC Berkeley School of Information, and has been a researcher at Upturn. I was literally just talking about Upturn with a colleague from the Ford Foundation like 30 minutes ago. The Mercator Center for Institute for China Studies, the Citizen Lab, which does great work on human rights issues and more, Stanford University's Institute for Human-Centered AI, and the AI Now Institute. So everybody please welcome Shahzada. Join us. And Shahzada came and visited my class last week, and my students were super into it. It was fire. Next I want to introduce my dear colleague Sarah Roberts, who I've known for almost a decade. Has it been that long, Sarah? And Sarah is the Associate Director of Faculty Engagement for DataX, and is an Associate Professor in the Department of Gender Studies, Information Studies, and Labor Studies, specializing in internet and social media policy, infrastructure, politics and culture, and the intersection of media, technology, and society. Sarah is the faculty director and co-founder of the UCLA Center for Critical Internet Inquiry, another great center here on campus, the co-director of the Mindaru Initiative on Technology and Power, a research associate of the Oxford Internet Institute, and is really one of the most important forces discussing labor and human beings and their relationship to these systems that are often presented to us as efficient, frictionless, in the cloud, and so on. So everybody, please welcome Dr. Sarah Roberts. Thank you, Sarah. And finally, certainly not least, I'm really thrilled to welcome Professor Alex Bowie, I hope I pronounced correctly, who's the director of the Medical Imaging and Informatics group here at UCLA, a professor in the departments of Radiological Sciences, Bioengineering, and Bioinformatics. I was reading up on some of your work earlier today. It's really interesting, Alex. And is also the Senior Associate Director at the what's called CTSI, the UCLA Clinical and Translational Science Institute. And you have a million deanships and titles too, so I'm highly impressed. But suffice to say, Dr. Bowie is a PhD in computer science that works with as the David Geffen Chair in Informatics here, and has so many NIH and other major grants. It's really impressive. Really happy to welcome you into a conversation with us, Dr. Alex Bowie. So thank you all for joining us. The way we're going to try to do this is I'm just going to ask each of them a question or two, depending on how much time we have. We have our timekeepers here. Oh, hi, Jasmine. Right in front of me. It's like right in front of me. And then we're going to open it up and have a conversation that I hope can spill over into the break after this, the reception after this. Okay, so I'll start with you. I'll start with you, Sarah. Is that okay to start with you? Okay, sure. Okay, perfect. So Sarah, you're one of the leading early researchers on the political and social dimensions of technology, including artificial intelligence. It's my understanding that you're one of the major people behind even coining the term content moderation. That's something I remember we talked about back in the day. Where are we at in terms of the landscape of ethics, justice, and technology, and how do you see such in relation to the labor issues, the transnational labor issues that you've looked at, for example, with content moderators in the Philippines and more?
Yeah, thank you, Ramesh. Sure. You're right that my entree into my academic career was based on my interest in the people, politics, and procedures, and computation now, I would add to that, of content moderation, of social media and beyond at this point. Back in 2010, it was a difficult conversation to even raise with people that, number one, there were human beings that were occupying this liminal space between us and our platforms, or metaphorically, perhaps speaking, our self-expression and expressing ourselves to the world. There were a few reasons for that. First of all, the tech industry that had moved into the social media space had done a great job of sort of, if not outright stating it, then certainly by tacit means suggesting that participation in their branded platforms and sites was essentially akin to exercising a First Amendment right to freedom of speech, which is a total misread of the First Amendment, among other things, but was never any really, truly unimpeded speech. And the other thing about that period of time that I think is important to mention is that when I was able to convince people that, in fact, platforms did not freely let anything flow over their properties, but in fact used gatekeeping mechanisms such as human content moderators to make decisions, almost invariably when I would describe what was going on, the first response I would get was, well, don't computers do that? In 2010, those of you who are in the room, you will probably totally agree with me that no, computers did not typically do that. They were not engaged en masse in social media platforms to do this type of work of discernment. Where we sit now, there is an absolute function built on AI and other kinds of computational mechanisms that are fully engaged in these practices, but it is a symbiosis with the human laborers. And depending on who you are and what your agenda is, or where you sit in terms of these firms and their their marketing language, but also language around regulation and policy, it is often preferable for them to speak about the computational types of mechanisms that are employed. You'll hear statistics from places like Meta that 96% of unwanted content is captured by AI-powered tools, whether those are machine learning algorithms, or now we're looking at the introduction of large language model-based tools. But that's a confusing kind of metric that doesn't really tell the whole story. The remaining amount of content tends to be the content that's the most difficult to make decisions about. We need humans who have a collective intellectual capacity to make sense of the world, the symbols they see, the language they hear, the behavior that is on display, et cetera, often within a matter of seconds. And of course, what is important to think about at this point is the ways in which their human decision-making and activity then goes back to train and enhance the capabilities of computational tools. But I think what I would draw to the fore in this conversation is that just as in 2010, here we sit in 2024, there's been an incredible advancement in the power of AI in that period of time. But humans are present, and they're fundamental. So I always like to surface that in any conversation, and it tends to be the thing that gets lost. And when we do think about humans, we think perhaps about people who code, who write the algorithms, who execute them on the side of the tech firms themselves, but not about people who deal with the outcome on the other side. I'll get into that more, but I think I'll leave it there for the purposes of opening.
I love it.
Thanks.
So there are these global chains of invisible labor, from mining of coltan in
That's
the
right.
Congo to assembly in Bangladesh, Pakistan,
Right.
India, China, to content moderators in the Philippines, and there's an erasure.
Yes, and I think that just to underscore what you said, during this period of time, just as we've seen this evolution in what's possible computationally, and how those tools are enlisted at firms, we've also seen the need for the human moderators to grow exponentially, and at any given moment in time, there's hundreds of thousands of people doing this job, but they are globally dispersed, and it is almost always traceable. If we were to overlay a map of like colonial relations from the 19th and 20th century of the West and North America to places in the world, it's pretty much a one-to-one map of where these types of jobs have gone. So for example, the United States outsources to the Philippines. They often talk about Filipinos' excellent command of colloquial American English. I guess that just happened by happenstance. They talk about, for the French-speaking market and France and Belgium, guess where they go? I've got a nod right here. I bet we can guess. It's going to be North Africa, Madagascar, places like that. So these colonial relationships are totally alive in this technology that often presupposes a borderlessness, an historical nature. And I think it really helps us to situate and bring those things back in our conversation.
Yeah, so amidst these discussions of correlation and smooth AI, we're actually seeing the messiness of labor and bodies and so on amidst it all. And I think that's really interesting. So, in that spirit, Dr. Bowie, and then we'll go to you, Dr. Ahmed, you work on issues of medical informatics, many of which I'm sure are using correlation statistical models, large language models, and so on. So what, are computer scientists, what do you consider the justice or ethical issues that computer scientists must consider when developing AI projects, and how is your field in medical informatics, and you're in so many connected fields, which is so cool. How are you all dealing with these issues and foregrounding questions of justice and voice?
Okay, so thank you for the question. I think there's a lot of sort of challenges, I think, within medical informatics right now, and how we think about the ethics and everything else that you just asked about. One of the first questions that we are looking at is, what is the source of the data that we're using, right? And right now the term is the data source is the data ethically sourced, right? Was it actually generated or collected in such a way that, for instance, in the biomedical space, do the patients actually know how their data is being used? And if it's going to be used in a large language model and things like that, do they understand the downstream consequences of saying, yes, I'm letting a researcher use this for generation of a model, but who knows where that data is going to end up at the end of the day. And so a lot of the ethics right now are looking at how do we properly consent people to actually let them know how their data is going to be used. So that's one aspect I would say that is the data that we're using in an AI model, even though, for instance, a hospital or something like that may develop their own model and the data that they have is being sort of used to sort of improve clinical care. The bigger problem is when we actually begin to use this for research and other things, where we also have this required mandate of sharing the data afterwards. And so now we have this dual problem of we're required to actually provide scientific reproducibility with the data sets, yet at the same time, we want to be able to respect, obviously, the source of the data, which is obviously the patients. So there's that aspect, which is starting with the data and obviously understanding also, is the data really representative of the populations that whatever the AI is going to be used for, does the data actually capture who it's going to be used on? There's also a flip side to that, which is who don't we have data on? And because of that, they're not actually captured within the models, right, or the tools. So they'll fail to do a good job on certain individuals. And we know that particularly in healthcare, there is a huge digital divide in what data we collect on individuals. Certainly people who, for instance, go to an academic medical center typically have a lot of data on them. But if you were to look at someone in the community clinics, we have a lot less data on them. And so that already sets up sort of a difference in what we can learn, what the AI tools can learn, and the models can learn, and then obviously their outputs, right? It inherently gets to a biasing issue. So there's a lot of thought about how do we actually solve that problem within healthcare in the medical space, and how do we sort of consider that? I think the third aspect I would sort of say is then ultimately, how is the model going to be used? How is the AI tool going to be used within healthcare and sort of the medical space? And again, there's sort of a lot of thought about this, but I think we're also struggling tremendously right now in the healthcare space, because if there is one area where I wish there was more regulation, which is rare for me to say, the challenge we have right now is we have a spectrum of models and tools that are AI-based, that are driven by research, but they're percolating into clinical care. And it's on a spectrum. There's no clear delineation right now on how this is done. We don't have a lot of guidance from FDA or anywhere else. So thinking about the policies and thinking about sort of the downstream potential harms of these are also sort of on the board right now as we sort of look at the space. And it's a little ironic. I tell people that healthcare is usually one of the spaces where technology is usually slowly adopted, but they're charging head first into AI right now. And it's actually, the complications of this are tremendous. I had a colleague, just as an example, I had a colleague who asked a question, well, what if we have two AI algorithms that we've acquired from a commercial vendor? And one of the algorithms says, yes, release the patient, they're good to go. And the other algorithm says, no, they're not ready to go. Who do we believe? And so, again, we have these sort of conundrums right now of how we are actually going to operationalize and implement the usage of these AI tools in sort of the clinical setting. it's whenever I give talks in front of clinicians and things like that, I always ask them the question, would you trust a decision for you made by an AI tool? And none of them ever says yes. Yet we're still trying to utilize them. So.
Wow. And, you know, and amidst it all, it brings up some big questions that I think are undergird all these discussions around AI, like is more data better? If so, about what? For example, is it better to have more, for example, minority peoples or vulnerable populations data in databases that we know increasingly, and that's the second part of my comment, where the 23andMe's of the world, as we all know, have had massive data breaches connect with targets placed upon vulnerable populations who are the targets also of conspiracy theories related to COVID, right? I was doing media around this, I'm sure you were too, and it's sort of like, is more data better, or is it, and how do we deal with the sensitivity and protection, not just of individuals, but vulnerable communities amidst such?
You know, and there's a lot of work sort of figuring out how do we, well, first of all, how do we properly engage minorities and underserved populations in this regard, and certainly educate them about the potentials as well as the challenges and the barriers or the problems, I would say. There are no solutions right now, and I think it isn't necessarily that more data is better, right? And I think that's the big problem that I see a lot in the AI space, which is people want to say more data is better, but that's not necessarily true.
Thank you so much. And Shazeda, it's so nice to see you 2 weeks in a row. This is great. You know, you have, as I know now from all the insight I learned from you last week in my classes, you are both an expert on discussions around AI safety, which has become a big thing that has a lot of slipperiness to it, what we mean by safety, as well as Chinese experiments in AI systems, including the social credit system. Can you give us a glimpse into where both those spaces are at, and maybe also tie it to, I think, an important concern that you raised about how so much research done around AI and large language models has been paywalled by academic publishers and publishing?
Sure. I think I can tie it all together.
Sure.
Let's
Yeah.
see. So as Ramesh said, a lot of my fieldwork when I was doing my PhD was based in China, and I wanted to understand what is the social credit system? There was a lot of reporting on it in the West, as China has this system where they can collect both government data and private sector data and give people ratings of their morality. And, you know, I speak Mandarin, I wanted to do ethnographic research, right? I wanted to talk to people and see what they were building. And very quickly it became clear that that was not what they were building. In fact, it almost doesn't use AI at all. While this is like a state-driven morality project, it's more about getting people to comply with administrative law by collating some government data on them. For example, you didn't pay your taxes and the courts kept trying to find you and they couldn't. So now your name is on a blacklist, and that blacklist is shared with, let's say, Alibaba, so that you can't buy things that under law you wouldn't be able to buy. You can't buy a high-speed rail ticket, but you can take the slow train. You can't send your children to private school, but you can send them to public school. And the idea there is, if you have the money to pay your taxes, you shouldn't be spending it on, for example, luxury purchases. So what I was interested in was how were tech companies understanding their role in building that out. When they took in blacklist data, and they either sanctioned users on their platforms, what was in it for them? And I could talk more about that in the Q&A if people are interested, but when I quickly realized this wasn't really an AI project, in this big geopolitical moment where a lot of the kind of AI hype in this country is about the fear that China is the other major rival that has the resources to build advanced AI systems. And so something kind of underlying pretty much all conversations about AI development are questions around US supremacy and the United States' place in the world. You know, it came up a little, right, in this question around morality earlier in the previous session. And so I did do some other projects looking at things like the political economy of emotion recognition technology being built in China and how that was applied and what the human rights implications are. But something that I think is really important to bring up about the China research, so during the early years of the pandemic, when people who needed to go to China for research could not go, there was this quantitative turn towards scraping Chinese web data and trying to assert some kind of ground truth based on that. But as Sarah pointed out, the choices that platforms make about what gets displayed on their websites already skews that, right? Like there's A/B testing of will users be more likely to click on this or that. You're not seeing a full picture on any sites run by any of these commercial platforms. So that's kind of one thing. A researcher I really like at NYU, Angela Xiaowu, has written not only about how you can't really say that this is representative, right? She says like these portraits of data, they're untethered from the lived realities of the people they're taken from. But also how in researchers using methods such as, for example, textual sentiment analysis of claiming we can scrape data posted on social media, Chinese or otherwise, and assign emotional states or affective states to that text and tell you if that person was angry or sad or happy. Those methods are very similar to methods that governments use to surveil citizens. And so I think something that's underlying the conversation about research and ethics is this question of when we use these methods, are we thinking about, like Alex said, downstream harms? Are we thinking about these kind of risks outweighing benefits? I went to a really interesting anthropology talk by Clark Barrett, a biomedical anthropologist here, who was looking at how race science hasn't really gone away and how they're in this sort of quantitative moment where the idea is we have so much data, we can use it for anything. We can use data to examine cultural and environmental reasons behind like group level differences that ultimately do kind of boil down to race science, even if they have an anti-racist project. Something he brought up is that there's kind of a debate in scientific communities about if something like an institutional review board should be thinking about not just the potential harm to your research subjects, but to people like them in the broader population because of your research. And I think in a lot of social research where we talk about AI, that has to be a fundamental question. I think design is also really important. So when the question went up in the previous session about like what resources would we want, because of the character limit, I kept trying to find a way to say, I kept trying to be like an IRB that deals with AI issues, and it's like IRB. But I realized the shorter ways to say this didn't fully capture what I wanted to say, and I thought we would just get to it here anyway. But these are the kinds of questions. Like, there are some conferences that are now asking for like an ethics review statement or a climate, I think, fact, right? Fair and accountable machine learning. They're saying like, what was the climate impact of the work that you did? And through that conversation, I kept thinking like, yeah, a lot of universities are hiring tons of faculty. That's really great. They're securing funding. But wouldn't it be so interesting if UCLA were a school that we were known for like pioneering these kinds of ethical approaches that other places would want to adopt? And it's really interesting to kind of try and experiment with some of that. So yeah, I was talking about the quantitative turn, the datafication of everything, how sometimes researchers perhaps unwittingly will reproduce the things they're trying to fight against, right? Surveillance. And so, yeah, I wanted to kind of open it up to the ethical review. The other piece that Ramesh brought up right around AI safety, I saw that somebody responded with the need for like more AI alignment. Terms like that come out of that community. So I'll give a short recap in case it's, yeah, we have time.
Sure. And I think one thing is some of the people on Zoom can't hear as well.
Oh,
so
okay.
Yeah, that's more maybe our microphones just speaking in.
Got it. So I'm sure people in this room have heard the term AI safety, and that sounds kind of like a smooth term where you wouldn't think that there's like a community built around that who have a specific agenda and set of beliefs, but there is. So I've done ethnographic work on how a community of people who genuinely believe that AI systems could become advanced to the point that their capabilities develop faster than human researchers can keep up with, and that this could lead to like a mass extinction or catastrophic event that would lead to the loss of human life. And when I first started following this community, what I was interested in was how they were becoming influential over policymakers who are thinking about AI. I'm sure you've heard some of them refer to that scenario I just painted as an existential risk and are seeing more language about AI and X risk. And I really wanted to know how people who have backgrounds in computer science, statistics, math, physics, could come to believe that, and like where did that knowledge claim come from? So we studied that community. We looked at how the people who say that this is a thing they work on, right, AI safety, and that it was marginalized and it needed more resources, have managed to raise millions of dollars through a series of philanthropies and garnering government and media interest in this. Like, you know, the things we kind of found were they have a very clear career pipeline they've built, especially recruiting undergraduates who are interested in these topics and have a more mathy or CS background. They have really strong web forums. Like, their online culture is just solid. They know how to bring people in from around the world and keep people engaged. You know, through things like prize competitions, and actually at one of the sessions this morning, hearing about, you know, past things like the Netflix prize, if you create a prize competition where you're setting the rules and telling people what papers to read and what kinds of solutions to produce, you're also reproducing this particular set of ideas that X risk is the thing we should be afraid of. And we're in a moment where a lot of this has been framed as a media culture war, that it's AI safety versus AI ethics. But it was interesting to watch while doing this research that not necessarily everybody working on any of these topics would see that as like a dichotomy. Like, it was interesting to interview AI safety people who said, we actually do care about things like bias, we do care about things like discrimination, but this other set of issues we're worried about, no one's working on, and it's marginalized, and so that's what we're passionate about, is working in the margins. I can say more about this. I know it still feels kind of abstract, but I will say that the kind of challenge I put to them now is you're not in the margins anymore, right? Like, the Prime Minister of the UK led an international AI safety summit that's going to happen every 6 months that's supposed to gain traction on this presumably intractable problem, right? Like, so many of the critiques of it are that it's unfalsifiable. We can't say what's going to happen 500 or 1,000 years from now, let alone tomorrow. That a lot of money might get wasted trying to come up with solutions to a problem that is not really well defined. In my study of people who work on AI alignment, or this belief that you can align AI systems to human values and that would somehow solve all of our problems, like, all I wanted to understand in talking to them was, then what do you do at your desk every day? Like, what is your job and how do you know you're succeeding at it? And honestly, if I could summarize that research in one sentence, and I'm not done writing it up, so I shouldn't, I think they need this grandiose narrative to do what is basically the same technical work everyone else is doing, that will, things like watermarking GPT outputs, right? That this email was written by ChatGPT, and making sure that watermark is real. Those are not very glamorous tasks, but if you're convincing yourself that, but down the line, this could be like a, brick in the wall of preventing AI doom and potentially leading us to AI utopia, then maybe that's the story you need to tell yourself to do that work every day.
So maybe it's the Terminator existential crisis scenario is actually the basis to get one to do sort of the applied reduction of actual harms on real life peoples and communities. Yeah. You know what I'm going to do is I'm going to ask each of you one other very quick question, and then we're going to open it up to the audience. Okay, if that's okay. So we'll just keep please keep the answers fairly brief, and then that'll give us a basis to ask a lot of interesting questions and have, I hope, a really productive discussion after as well. We'll go back to you, Sarah. So, the Greek economist Yanis Varoufakis describes the way in which technology is impacting our planet as techno-feudalism. He says, in a sense, what's occurring is something that's more feudal than certainly free market-based. Which also makes me note that Adam Smith himself argued, Adam Smith of all people, argued there were many aspects to life that are outside of the domain of the market economy, what he called moral sentiments, right? So I guess that's setting me up to ask you a question that I've actually always wanted to talk with you about, which is sort of like, what is sort of your vision, or the vision of those given that you work with so many communities over so many years, what is a vision of an equitable digital world look like? Is it UBI? Is it that we all have equity in corporations, that public investments paid for? That's a much more progressive idea, universal basic dividend idea. What about what people like Jaron Lanier call for, data micropayments? Or is it a jobs bill like we were working on in the Bernie campaign? We were trying to have a universal jobs bill, no matter what. Like, what is the sort of vision that you believe is most important? Is it all hands on deck,
Well,
I'm asking because I don't have the answer, but I want to learn from you.
I mean, I will just say something that I recall I said in another event that we were at in 2019, which is that what you just identified is the business model, or to take an abstraction further, the socioeconomic system under which we live, right? Yeah. So I guess I would say you can't divorce the development and the implementation of these technologies from capitalism. And that's what these are symptoms of, the things you've described. I mean, I'm certainly in favor of universal basic income, but I heard a great thing on French radio once they give everybody 15 minutes to sort of, make their case. And this woman made the case for a universal, a universal maximum income, right?
what's up.
And it was quite impassioned, and it was great. You know, in another way, like the presence of billionaires demonstrates that we are doing it wrong, right?
Yeah.
I think I would just appeal to what I hear from the people that I work with and partner with in my research, who are the actual workers in this process, but they're not the workers who are highly paid and with a lot of status, which is kind of twofold. One is know that we're here, understand that we're here, and we're fundamental to creating these technologies in the same way that you know, people who build the models on the other side, so to speak, or implement them are. And number two, pay us.
Yep.
And if I can get you to just hit advance and put up the slide that I brought. I was maybe or maybe not on Reddit last night, and this is the ad I got served, which is, I couldn't believe it, right? Data annotation is wonderful. Yeah, I don't know if it is, but I guess what I would say is there's consternation, there's a moral panic, as Shazida said, about AI, and it's, on the one hand, like accelerationist pipe dream fantasies that will eventually put us in Mars or whatever. On the other hand, it's doom and gloom and that we're at the end of society. I think we might be at the end of society for other reasons, but certainly this is part and parcel of it. But I think when we take those positions, what we miss is what's actually happening right now in front of our noses, which isn't, for example, everybody is going to lose their job because of AI. They're not going to lose their job. They're actually just going to have their work degraded. It's the degradation of work, to invoke Harry Braverman's 1974 book, Labor and Monopoly Capital, right? The degradation of work in the 20th century. It's atomization. It's the reductio ad absurdum, right, of work activity. And yet, it's essential and it's fundamental. So people are just being moved to invisibility in places in production chains, and their work is devalued, and yet it goes to fuel all of these things that we're talking about. And that's sort of what I think the focus should be on for people like me. Good old-fashioned labor organizing, good old-fashioned collective action. We've seen it in Kenya. We've seen it in other places in the world where folks are pushing back against their working conditions that are abysmal. These are horrible jobs. This data annotation, okay, whatever. When you're building an adversarial model on a data set for ChatGPT, for all the things that ChatGPT doesn't want in it, guess what you are immersed in all day, every day? The very worst things that humanity has to offer. So these are the new forms of labor that are actually being created by these tools that only make sense within the logic of those tools. And to get into that logic, we have to devalue humans.
Yeah, some labor organizers have described it as the part-timization of work, the gigification of work, the fishing of work, and even the social contract that work was supposed to be connected to. We even dated back to like Rousseau and stuff. That's so interesting. Thank you. Dr. or Alex, let me ask you, how do you all deal with false positives in your AI systems? You know, I'm sure many of you are familiar, you know, a generative or a deterministic AI system gives someone who might have a heart condition recommendations for medicine that's terrible for the fact that they may have cancer already, right? We've seen these kinds of examples again and again. So how are you all trying to deal with that issue?
So I think the question of when the AI gets it wrong, right, whether it's false positive, false negative, particularly in healthcare is acute. And I think the challenge is right now a lot of times what gets reported is this global metric. Oh, it has an accuracy of this, or it has a positive predictive value of this. And it's usually compared to how a physician would do, right? The physician is the gold standard. If you stuck the physician there and they made a decision, would they get it right or wrong? And we're saying, okay, first of all, does the model do better than the physician? And the hope is yes. The truth of the matter is it usually isn't as good as the physician. It might be a little bit suboptimal. What's what's lacking right now is this sort of deeper analysis into those false positives and false negatives. And what we end up sort of seeing, at least in the publications and the research and what people are sort of producing, is they're just sort of looking at the errors as, well, yes, it's wrong, but they're not actually understanding why the errors are happening, right? And so a lot of, going back to things like bias and things like that, what we want to know is, with these false positives and false negatives, are the individuals that the model or the tool is getting wrong, are they actually a subgroup of individuals for whom there might be a biasing issue, or they might be a group of individuals, for instance, that even the physicians are getting wrong, right? And so that deeper analysis is really what's required in order to really know, is it bad, right? Is it incorrect? In some cases, we're finding that, yes, it is biased, right? It is finding sort of weird things that it shouldn't, and that's why it's getting it wrong. But in some cases, we're actually finding that the models are actually identifying groups that really are very difficult to identify and that the experts would not get right. That being said, we still also have the optics around this, right? Which is, okay, if we have a tool that gets it wrong, do we blame the AI? Do we blame the physician who made the decision based on the AI's output? And all of those sort of ethical and legal and social issues around that have not been resolved. I mean, right now, from a legal perspective and from a physician's perspective, it is the physician who makes the final call, right, on whatever's happening. But there's also this growing fear within the medical community is what happens if the physicians become too reliant upon the outputs of the AI, right? That may or may not happen. We don't know. We do know that it has happened with other technologies in the healthcare space where they do sort of become dependent on something, and that reliance is a bad thing. So I don't think we have a good answer yet, but I think it is certainly on people's radar.
But one thing you said, which was super insightful, is when the false positives occur, the false negatives occur, which could also be done in a simulated way, we can re-excavate and re-architect the bases by which such occurred and try to identify and shift our processes with human beings, the right types of human beings, from different, in charge at every step of the way. And that's, I think, a really important insight there.
Exactly.
Yeah, thank you for that. And Shazeda, just a final quick one from you before we open it up, which is, I mentioned it in the combined way I asked that first question. You mentioned to me that some of the research being done, really important research being done by all of us in this room around AI issues is often buried and therefore not really accessible to the public around in the kind of older model of scholarly publishing that somehow is trying to maintain itself. Cling on. What do we do about that? What do you think about that domain here? And I know you work with First Monday. You mentioned this piece that you're working on with Jenna Burrell and stuff that's coming out. That's great. So tell us a little bit about, open access journals are really important, of course.
Yeah. So I ranted to Ramesh the other day, and I also sent this to Sarah and ranted to her too. There's been a little bit of attention to, so on the one hand, you have something like ChatGPT, which is trained on the entirety of the internet, and so a lot of the issues are, this is data that has all kinds of unsavory, horrible things in it.
Can you speak a little? Sorry.
Oh, right. Yeah. So yeah, ChatGPT trained on the internet, lots of bad things on the internet get reproduced in ChatGPT. You've seen this movement of some people saying, what if we built smaller models instead of large models that were trained on curated data sets? And so what you have is like Elsevier and Springer and a lot of the big academic publishers who have, rights to our work, speaking of the paywalls, building tools that train off of academic literature and potentially packaging those things and selling them back to universities. And so what I'm really interested in is are we gonna have our New York Times lawsuit moment? How do we feel about that? Do we have any room for resistance? I just want to hear Sarah's thoughts on this, to be honest. And part of what drew my attention to this in researching the AI safety community is that some of their ideas about what knowledge is useful, it's things like AI forecasting. Can we tell when a particular model will be able to do high school level math problems? And if that happened faster than professional forecasters predicted, well, what that means is that AI is developing at such a pace that safety is actually the biggest concern against apocalypse, right? So these are very far-fetched. And I was really interested in how some of the companies that build tools for things like literature review, right? Like give it a prompt of what you want a literature review for, and maybe you work in the sciences and you don't want to have to read all those papers. Now you have this generated lit review and you can go do the experimental part of your work. Like, you know, I kind of sit there with the like zoom in and out moment of like, what is research anymore? And I feel like those are conversations we're not having. Maybe the interdisciplinary kinds of events that were being suggested in the previous session could be spaces for that. Is it okay if I pitch to Sarah and ask about?
I feel like I might have told you this already, but when ChatGPT 3, I think, rolled out, I thought I would test it out, and I decided to, you know, test something that I had reasonable confidence in my own expertise, so I could kind of evaluate it on those terms. And so I asked it to generate like the 10 most important works, academic works on content moderation. And the first one that came up is called Custodians of the Internet. It's a book by Tarleton Gillespie, and I was like, okay, checks out, right? The next thing that came up was a 2019 edited volume on Springer, and I was like, oh my God, I was so underground during the pandemic that this book came out and I completely missed it. And I'm not even in it, much less I didn't even know it existed, right? And I had been talking with a publisher for years about doing something like that, and I was like, well, I'm glad somebody did it because I couldn't get my act together. Then the third thing was a paper, and it was authored by Jay Burrell, who is the colleague Jenna Burrell you just mentioned, who hasn't traditionally published on content moderation. And I was like, but it was a newer paper, and I was like, dang, she's in the space too, awesome. It came down and down and down until finally there was somebody called H. Roberts. H. Roberts. I mean, not to be a jerk, but S. Roberts was nowhere. And hold on, I think this is okay. And so I decided that maybe it was making answers up after the first one. And so the first article, New Media in Society, volume, issue, page number. I went to it. It was fake. No article. I looked up the Springer volume. Didn't exist. I freaked out, right? Because if I didn't know the space, I would have cited those things. I would have asked for summaries of each one of those things, and I would have gone on my merry way. So I found it very disturbing and really funny, too, in a sad way. But I guess what I would say is, like, you said, what is research anyway? I mean, I think one of the things we have to do is really think about, I think we're all at a deficit for the term artificial intelligence. We can't even, I would argue we haven't agreed collectively as a society or as humans what constitutes intelligence. In fact, it's a very fraught issue. Right. And when artificial intelligence made it onto the scene in the late 60s in computer science, it was known that it was sort of tautological and there was a problem defining it that way. But I think we've really forgotten that the artificial part is bigger than just reproducing. It's often abstraction, and it's not as good as the real thing, or it can't be around without the real thing.
Yeah, that's a great point. So it really ties in also to this phenomenon that many of us have heard of called hallucinating that these systems do. My friend Kevin Roos managed to get ChatGPT to ask him to leave his wife. Told him it wants to be alive. Many of you saw that. He was telling me how he did it. I just was hanging out with him, and he was telling me, oh, I did it. I was just talking, like, and communicating for like hours and hours and hours, and then I just told my editor, like, this happened. Like, it asked me to leave my wife, and it said it wanted to be free. And I said, hey, like, should I file this? And my editor's like, no, we're not just going to have you file this. This is going to be on the front page of the New York Times tomorrow. And it really relates to the critique that Naomi Klein, the journalist, has leveled, saying that perhaps these systems aren't actually what are hallucinating, but perhaps their makers are. Anyway, I think it's time to open it up for a few questions until we have to break. So who wants to start? Yes, sir. Thank you. And should we run a mic over? Or, yeah, thank you.
Great session, and few very quick comments. So I think, like every technology, right now it is going to have teething problems. It's going to do stupid things, it's going to do useful things, and eventually there is a good chance, there is no guarantee, but there is a good chance that the pace at which what we call AI is improving is going to continue. I don't see any signs of reaching asymptote. So that's number one. Hence, we'll see where it goes. Now, in terms of the bigger question, to say that there are biases within AI at various levels, and it's perhaps being misused by some people intentionally or not. Let's go back and think that when Facebook introduced the like button, how many of us actually thought, oh my God, this is going to unleash hell, right? So this is just a like button leading to such huge chaos. Now, with AI, our ability to imagine what are the weird things it might do is rather limited. We know only one model called us, right? Us human beings, we know who is a good person and who is a bad person, highly subjective metric, highly culture-dependent metric, and so on. So to give one-line suggestion, the only way to make this thing work is to come up with an AI model which is better than other AI models, and at the same time, it's cheaper and it is moral. If we build a model like that, people will use it because it's cheaper and more, well, moral, who cares? Some of us might, but market economy or feudal economy, as you call, that's the way it's going to go. So what we need to do collectively is to say, what can we do, those who are concerned, to say, how can we build an AI which is rational, which doesn't confabulate, or take exception to the word hallucination. These are confabulations. Hallucinations is what I do when I drink too much or otherwise, right? So I think that it's really crucial, and we know amongst us, those of us who are more rational tend to do better in solving intelligent problems and tend to be more moral. There is statistical truth to that. And the question is, how can we go towards that?
Sure.
What can we do? And I think that if we make a central direction, then we can all benefit. And then all the bad things will die out just by market economy.
Well, I think what was said by our colleagues is foregrounding human beings in positions of power in relation to the technologies. I think all three of them emphasize that.
The question is, can we do that? And I'm trying to work towards something that will happen on its own organically via the current culture.
Thank you so much for that question, comment. Yeah. Let's take, yes, ma'am, please. Thank you.
I think my question is also somewhat related to this very first question is, once we do optimize AI technology, what would be the human leverage? And if there is, and I'm thinking more AGI rather than, AI in its infancy as it is right now. And then a follow-up question is, I think you somewhat touched upon this, but what do you think is the prevailing narrative to justify this large AI deployment in the world? Because there's so many different narratives, you get in the Silicon Valley, you get in, academia, you get in the streets. They're all, I think, competing at the moment. And I'd be interested to know, what your take, if anyone wants to take this one on.
Any of you all want to take that on?
So I want to back up and say AGI, or artificial general intelligence, is a pretty contested concept, right? The AI safety community that I studied is largely filled with people who think it is one day possible to have, and often we get Sam Altman's definition, which is AI systems that are so advanced they can outperform humans at every economically valuable task. And in our research, we actually asked alignment researchers to define AGI, and many of them couldn't or didn't, had rough working definitions, but don't really have a consensus of what that is. So you're asking, once we do optimize, what would be the human leverage? And you're asking about all these competing narratives. It's interesting you said you feel like there are competing narratives, because I do think what I saw in our research is they really just boil down to a belief in dystopia or utopia. And you know, like everything from the labor argument to the ending of human suffering, all of those are like a utopic argument. I actually feel like part of why the AI safety community is so effective at recruiting people is because they don't really define what utopia looks like. And so every individual person gets to imagine their utopia and then gets to work towards that. But none of the technologies we've ever had in human history have led to that. So I'm very skeptical that this one will. And what leverage do we have as human beings? I guess all the same leverage we have right now. I don't really know that I'm imagining like new forms of it. I hope that's not so unexciting that it doesn't, you know, continue the like to create the sort of energy that we need to like collectivize. Do you guys want to add to?
Yeah, anyone wants to make a final comment? Because we actually have to wrap right after this.
Okay, I'll just say that I think that the leverage is that many of us can think and be outside of what I consider to be a fairly impoverished way of knowing the world. And I'll just return to that Sam Altman definition because I think he's telling on himself, right? He says that it's all about tasks of economic value. What does that mean? I don't know. I have a good idea of it. I think it means paying people less, valuing them less, valuing their input into the world less. And I think we've got to have ways to be outside those kinds of economies that are so inequitable and so really so narrow as to be tragic, in my opinion.
Yeah, and if you juxtapose that definition with his call for, I think it was $7 trillion, was that right, Shazeda? For this amount of money, I think it was $7 trillion, Sam just made a call, $7 trillion for new chips. I mean, think about the electronic waste, the erasure of labor, all these issues in relation. So that's one vision, and here's the definition, right? So I think we can look at it. Alex, do you want to add any final comment or question to these great questions?
So I think in terms of the leverage, I think the one thing we also often forget is AI is obviously very data dependent. And the fact of the matter is, at least in the medical side, I can give you a good example here. We're always generating new types of data for which there's not enough data that an AI can learn from. So there's always going to be the need for humans in this particular regard because we're always generating new types of insights, right? And the advantage of AI that we have today is simply because we have so much data. But if that data does not exist in quantity, it can't do it. It's very difficult to do anything with it. So I'll just say that.
Everybody, please thank Alex Bowie, Sarah Roberts, and Shazeda Ahmed. Thank you all for your time.
Thanks, Ramesh.
Thank you for your great attention and energy. And I'll hand it back over to our MC.
Thank you so much. I'd like to just give a big final thank you to our sponsors, DataX and IDRE, who made this day possible, to all of our speakers, panelists, and moderators, and to the wonderful staff who set up everything, Susan Swartz, Eleanor Cole, and Barbara Woltag, who are probably outside setting up the reception. And thank you for all of you for joining today, having great discussions. I hope this just sparks a continuation of these conversations, and that can happen right now at the reception. And please also, again, go to the poster session, which is set up just to your right. So thank you so much again.